Sure. Hi, this is Manish Bhoge. I work as a data solution architect with EPAM and currently working as a Gen AI platform architect.
All right, let's get started. So what we will be talking today about is basically we'll introduce, basically our presentation is about the Gen AI platform implementation within fast-moving consumer products company. And we'll provide a bit of the background in terms of what's the goal of the overall program, what the structure of the program. Then Manish will deep dive into the target architecture and some perspective accelerators that we gained from this activity. And then I will deep dive into the client's data ecosystem and scope, and we'll finish with some practical steps and or tips that you might want to consider in case you would like to join a new Gen AI engagement in the future. And we'll have some time reserved for the Q&A. So let's get started. I have a quick question to everyone. Have you ever tried surfing? And I will give you like a few seconds to relate. So I guess for those who did have tried surfing, they would relate these things. When you surf, you first have to spot the wave. You understand it's coming, and then you paddle, you work really, really hard, and then there appears the moment when you have to push yourself and stand up, and then you start just enjoying the process. But of course, you also have to sustain on the wave to make it to the beach. So yeah, I mean, if you don't catch the moment, you just miss the opportunity and you have to wait for another wave. And I think this is something which is happening with Gen AI in the industry right now. Companies are really trying to understand what is the best moment to catch the wave and how do they catch this wave. And our client is not an exception. So our client is a fast-moving consumer goods company, a global one, and they produce various products primarily in hygiene and health areas. So think about of various cleaners that you use in the house, dishwashing detergents, some sort of medicines for upper respiratory analgesics and all this stuff. And they have quite an extensive department of marketeers. And why I'm mentioning this is that the client decided to tackle the problem that marketeers are so occupied with many different tasks. And some of these tasks are taking so much time. So there is definitely an opportunity to improve the productivity of marketing department and see where Gen AI can be instrumental to accelerate their work. So basically, the client have come up with a few buckets of the Gen AI use cases that they wanted to test with Gen AI. And we can divide these use cases into three main buckets. So the first one is insights. Just to provide you the background, the marketing department in this company spends a lot of time and they have to analyze a really vast amount of information when they are driving their decisions regarding the brand evolution. So basically, there is a lot of data, like from key market research providers like Nielsen IQ, Hunter, and others that they have to analyze in order to understand market trends, consumer trends, brand perception, and many, many others. And this is a great potential for Gen AI because Gen AI would support the marketing team in order to consolidate the key learnings and distill the actionable insights. The second thing that you can think about is product concept drafting. So basically, again, a lot of time spent on just producing these words that you see in the package and the words that make you make the purchase when you're looking on the shelf. And there is a big sign standing behind each of the words. So basically, again, it's a very good opportunity to use Gen AI in order to come up with at least very draft version of this product concept, so that the whole life cycle of product concept origination can be accelerated. The second bucket of the use cases is the productivity. So think about it from like many angles. There are lots of use cases that we are considering, and they are really diverse. So just an example, it can be brand performance analysis, media spend analysis, brand strategy creation, and many others. So this is the use cases where the team spends a lot of time on firstly collecting the data from many sources, trying to get the insights from this data, and then drive to the conclusions and next steps. And the last bucket is basically creativity, where you would adopt the local digital assets to various markets. And by adoption, I mean not only translation of the messaging, but making the messaging itself appealing to the audience, and making the images, videos appealing to the audience as well. And just for the further reference, I will name these use cases as products. And opposite, we also have designed the Gen AI platform. So why platform comes into the play? The client started to think of Gen AI initiative as a scalable initiative from the very beginning. And Manish will talk a lot more in detail of why it's important to have a Gen AI platform within their organization. But just to provide you a bit of a teaser, this is a platform that is sitting on top of their traditional data platform, and it provides a lot of capabilities like cost control and cross-charging, being able to flexibly add models, because Gen AI is a fast evolving space and new models are appearing quite often. And then RAG as a service, and of course enforce data governance and best engineering practices. So how our engagement is structured? So basically, we divide our engagement into key 3 areas. First will be discovery and design. Second one is implementation. The third one is scale up. Quite typical, right? For quite each engagement, I would say. What are the peculiarities for our Gen AI engagement? So basically, a lot of emphasis within discovery and design was to understand how the existing traditional data platform is structured with the technology stack, and how we can align to existing technology landscape and standards. Obviously, we are talking about Gen AI implementation, and we've been looking a lot into understanding what vector database should be selected, what guardrails should be selected, and what model garden should be selected. From use cases perspective, it's important to mention that the products, the time that is spent on regular activities within marketing was measured, so that we are able to then prove the value that the Gen AI investment worth it, so that we can compare the time that was spent on a particular activity before Gen AI and with Gen AI, and show the quantitative result. And also responsible AI assessment is super important in this context, because we are talking about how do we avoid hallucination, how do we make sure that data privacy is in place, how we do avoid IP infringement and other problems. It's important to mention that EPAM has been not dealing with all of this on our own. We are in a very tight collaboration with the client and their consultancy partner of choice. What I want to highlight here is it's really a teamwork, and it's a very good collaboration between the teams. And I think each part here from this slide adds a lot of value to this entire program. But what EPAM brings to the table is definitely engineering excellence, and I think many of you have heard that a lot. But this is the case where I really felt it. So we were very instrumental in terms of aligning the target architecture to the existing clients' technology landscape and data platform maturity. And from product's perspective, we were bringing a very extensive data science expertise, and that helped us to design for the model evaluation from the very beginning. And of course, our strong partnerships with key technology vendors played instrumental role in terms of addressing any problem. So this is a bit of the introduction of what we are doing and why we are doing this. With that, I will want to hand it over to Manish to talk about the architecture.
Thanks, Volga. Okay, so let's dive into how the platform is built. Let me just give you a quick overview. The architecture of this generative AI platform focuses on making the latest foundation model easily accessible to the product team. So there are different product teams who are building their products and the application on top of this platform. And at the same time, promoting responsible AI use in the consumer good industry specifically. We have used a flexible model garden approach here, which helps team to handle multiple LLMs like Azure OpenAI, Anthropic on Google Vertex, and all these model usage effortlessly. Throughout this implementation, our priority was to ensure responsible AI practices, and that's why we built in a guardrail which play a very key role here, providing a secure and ethical way to work with these advanced models, right? This platform is powered by Databricks Mosaic AI component, which is the heart of this entire platform. I'll talk more about it in detail once I'll take you through the flow. But what is important is it makes simple for the team to tap into advanced AI capability using this platform. Plus, with a smooth CI/CD processes, right? So it's easy to develop or deploy generative AI application quickly and efficiently. So this way, product team can focus on creating amazing solutions, right, without worrying about the tech and the frameworks behind it. What I really want to emphasize here is that the product team using the platform, not just building a simple chatbot. So let's focus on that part, because these are the complex workflow that they are developing here. It's not a just simple chat agent or simple document reading. Rather, they are creating sophisticated Gen AI workflows to support product ideation, brand processes, etc. So let me just walk you through how the platform components are utilized by these teams to develop their workflow. So if you look at the flow diagram here, the application user, which you can see on the leftmost side, they're interacting with this platform through the front-end application, right? And this front-end application could be OpenAI, ChatGPT Enterprise. It could be Retool or any bespoke application. So we have prioritized different front-end and the applications here in terms of using this platform. I'll just quickly talk about what these applications are. So the ChatGPT Enterprise give you an interface to interact with the backend in a very secured environment, right? So it's not as like a ChatGPT that you use, but rather it is specific to the enterprise. It uses the enterprise IDs and the authentication mechanism to interact with the model in the background. The Retool is a low-code, no-code platform, which we give it to the different product team through which they develop their own workflow. So as I mentioned, that it is not just simple chat application or chat bot, but rather they can develop the entire flow of the brand building and as well as product ideation. There are some teams, they came up with their own application. So we allow them to onboard their application onto this platform. So if somebody coming with their own Dockerized application developed in some open source tools, we govern them through this platform and we onboard them on this platform. Now that's the front end part of it. Now, if you move further from the interface perspective, right? So all the interaction through the platform happen through the interface. Now, this very important part in terms of building the gateway on top of the platform, which will allow user to authenticate it through their enterprise, right? So there is a active Azure Active Directory, which now we know as an intra, through which they will get authenticated. There is an Okta authentication, and the user will get identified as an enterprise user. On top of it, it also handles the load, right? So if there are multiple requests coming through the application, the API management layer helps into the load balancing. Now, let me directly go into the heart of this whole platform, which is a Databricks data intelligence platform, or all we know as a Mosaic AI platform, right? Now, the 4 boxes that you see, the model serving endpoint, SQL warehouse endpoint, feature endpoint, and the vector search endpoint, these 4 resources or the component of the platform help product team to develop their own application, right? So we are providing these endpoint as the resources to develop either as a RAG application, or if they want to develop their agents through it. Nowadays, we can create a very smart agent to kind of do a different activity, tool calling and all. They can use these endpoint to develop their own application. Now, every endpoint has its own functionality. So model serving endpoint will give access to the OpenAI model or any other model which we are using it. And it provides the logging to that model and the token information and everything, right? When somebody's interacting through the model serving endpoint. Now, SQL warehouse endpoint through which they can run a SQL query to the enterprise, right? So as we create the RAG pipeline on top of these model, and during the RAG pipeline, they definitely want to access some enterprise data. The SQL warehouse endpoint will help the developer and the product team to query the enterprise data stored in either in Databricks or any other data sources. I'll explain to you in detail that how they are accessing the data other than the Databricks. But let me just go to the feature endpoint, right? Now, feature endpoint also give access to the structured data as SQL warehouse endpoint gives. But on top of it, feature endpoint will also give the functions along with the features, right? So if there is a business logic which we need to develop as an endpoint, we can also design that in the feature serving endpoint and expose that function calling to the application. Now, how it is different from the SQL warehouse endpoint? If the people are not very familiar with the SQL and they just want to kind of just give a call to one API and get the response, feature serving endpoint will make that kind of interface for them. Now, very important part, which is a vector search endpoint, right? Now, this is where the whole knowledge and the context gets stored. So the data gets stored into Databricks Delta table and vis-a-vis eventually stored into vector index where it get vectorized through the embedding model, and then it is accessible for the RAG pipeline, right? So whenever you want to kind of do a text-based search or detailed search using the endpoint, you need to kind of draw a context from the data. The vector search endpoint will help to build that. So all of these will get covered as a functionality. Now, there is very important aspect which I want to mention here is the Unity catalog, right? So Unity catalog is a central repository of all the metadata information that you can see on this box, right? So it maintains the interaction of all the information that is happening through these endpoint, plus all the data that is been used either as a structured data or an unstructured data. Unity catalog maintain the governance and the schema and the role-based access for all of those. So again, if I call it out, this platform that as a heart of this whole platform, the whole solution, the Unity catalog is just that wall which allow all interaction and then make sure that the access is given properly to all the different data sets and to the different models. Now, another thing which is very important to understand here is the inference tables and the system table, right? So underneath of Databricks, these tables basically maintain the interaction with these endpoints which you see on the top, right? So as we are putting a lot of governance here, and we also need to understand which team using which model at what time, what information that they are sending it, what is the token that they are sending to the model, and how much they are accessing. All that information get logged into the inference table and the system table. I'll discuss that in detail in the next slide, but then these table will help us to kind of do a chargeback to the specific product team, right? So as we give this platform them to use and build their own applications, we are able to charge rightly in terms of per usage or per user charges or per team charges, right? So it's a chargeback mechanism that we developed as a part of this platform. Now, on top of Databricks, as you can see, there is a plethora of tools like LangFuse, LangChain, and some of the AI services. They play a very important role in terms of prompt management, in terms of orchestration, in terms of the guardrails and all, right? So we use Azure Content Safety as a guardrail to make sure that we are not passing any wrong information to the model, putting right checks and balances and the compliances through it. And as we all know, LangChain play a very important role in terms of building those workflow, capturing all the logs, capturing all the information, and store it eventually to the Azure cloud. Now come to the rightmost side of the box. Now that's where the Azure services sit, right? And let me start with the top, which is Monitor, Azure Monitor. Now that is where it is capturing all the activities that is happening in the platform, right? So the activity in terms of monitoring the model usage, monitoring the SQL, and the unstructured data usage get logged into the Azure Monitor. On top of it, we also generate the alert. So if somebody is exceeding their limit in terms of the threshold, or if they are hitting to some errors while calling the models, right? So all will be maintained through the log analytics and the Azure Monitor, and we send a specific or detailed alert, the email alert and the different mechanism of sending the alert, and user get notified about that and the team get notified about that. Now let's come just below to that, which is Azure OpenAI model. So we use that extensively in terms of getting the responses from the LLM. I don't need to talk more about it, but then let me just go and touch upon the container services and the data lake storage and the app services, right? So as I mentioned it a very early, that there is an application which has already been developed as a Dockerized image or the container. We provide the hosting of those services on the platform through the container registry, right? So we allow the user who have developed their own application may not be using the tools which are already there in the platform, but they need to get governed by the platform. So we put all the checks and balances. We allow them to kind of register their instance in the container registry. So that covered the platform part. But then the important part, which I told you, that in terms of the data access, right? So there is a lot of enterprise data that we use it, right? And the content from the marketing side. So the below box is all about the data, right? So the very rightmost side are the unstructured data. Now this unstructured data is like combination of PDF, PPTs, the Word document, Excel sheet, right? So whatever document that marketing team has accessed or secured so far, or they have collected so far, will get exposed through the Databricks volume and eventually to the vector index and available in the vector search, right? So all of these content are available for any context building, any knowledge base, further for any RAG application if somebody is developing agent. So it will give a lot of knowledge to that agent through this vector index and the vector search endpoint. Now, there is a very interesting part which I want to highlight here. Let's suppose if a marketing team has a huge set of slides and the PPTs, what we are doing is we are converting those PPT into images, and we are sending those images to a model to get the detail about what is there in the PPT, right? So that's very interesting and innovative approach that we used in this implementation, where anything and everything, whether it could be images, it could be PPT, PDF, Word document, Excel, you name it, any kind of unstructured data, we are able to use it and make it as a knowledge base through the vector search endpoint. Now come to enterprise data, which sits in middle. We use a lot of data from the Databricks in terms of the data coming from the sales numbers, the historical sales and historical product informations and all that data been accessed through the Unity catalog, right? So it's just a Unity catalog sharing through which we get the data into the platform and start using through a SQL warehouse and endpoint and the feature endpoint. Now, if the data is sitting outside the Databricks, let's suppose if it is in the, say, Google Cloud storage or somewhere else, we provide the data sharing through which, like, not we, but as a part of the platform, through the Databricks, we give the data sharing capability through which the application team and the product team can access the data even if it is stored outside the Databricks. So this covers the whole platform capability in terms of building their own applications and their own workflow. Yeah, Volga, we can move to the next slide. Now, let me go to the little bit in depth in terms of how it has been used as a part of under the hood. So as you have seen, there are multiple endpoints as a vector search endpoint, feature serve endpoints, and model serve endpoint. All these endpoint, as and when it has been used, it has actually been captured into an inference table, what we call as a payload detail table and the usage tracking table, which basically capture the information about each request and response. So when the request and response are coming from Retool or ChatGPT Enterprises through API management, all the data and as well as the token that is being used through these endpoints get captured, and we are able to precisely find out that, okay, how much is the usage by a specific team, right? Whether it's a structured data or unstructured data, because we are covered with all these endpoints in the inference table. Now, with that, we are also able to find out that, okay, how much compute and resources they are using. So all in all, along with the uh, uh, the cost of each and every token, we can also get the information about what they are sending to the endpoint. Right now, there are tools. So like Retool and ChatGPT has its own pricing. We can give the pricing for platform also. So the customer is able to use the holistic pricing from all of these components, not just from the licenses of specific tool, but also the usage, and as well as the pricing going ups and down for those usage, right, for the structured and the unstructured data. So this is how we are able to kind of govern as well as do the FinOps reporting for this entire platform. Yeah. So yeah, Volga, I think we can go to the next slide, and then okay. So for the prompt management and the orchestration, right, as we are advancing this platform to the next level, where we not only just create the pipeline, but also do a very good orchestration in terms of managing the multiple workflow, as well as maintaining the prompt. So there was a requirement from the business in terms of managing their own prompt, because they are the right consumer, and they are the people who actually write the prompt for all of these workflow. So they want to maintain, they don't want to go into the workflow and then deal with the code and change the code and change the prompt there. They want to maintain the prompt separately, so whenever they want to make the changes, they can do it, and then also validate the model corresponding to their prompt, right? So as you would have used the chat GPT, right, you write multiple prompts, and then you see the response, then you again refine it. The same way business want to do that functionality through this platform, and that is where we provided them a prompt operation or the prompt management platform, where they through that they can create their own prompt first. So they understand the use case identification, as you can see on the topmost boxes, collect sample data, they build their own prompt, and then they run the cycle of evaluating it, right? So they do the evaluation through that sample data, evaluate the prompt, and then see that, okay, whether they get the proper response, whether the response is matching with the ground truth, right? So the groundness check and everything will be done here. And then once they satisfy, they deploy that prompt into the production, right? But very important part, even if everything is automated and taken care by the model, the human is very important aspect of it, right? So they also look at the human feedback, they look into the prompt, and then make the required changes if in case if they don't satisfy, and if the if their output is not matching with the ground truth, right? So this entire cycle can be maintained, and they can very well go to the previous prompt, right? So as we do the prompt versioning also here, they can go to previous prompt, and if they are not satisfied with the very current changes, they can very well roll back to the previous one and maintain that, which is a very important part in terms of the evaluating the model and then productionizing it for the further usage. I think that's complete my technical presentation. Volga, we can move further.
All right. You want to skip accelerators in sake of time?
Oh, or? Okay, yeah. So accelerators part is very important from the EPAM perspective. So whenever we work on any project, we always be very mindful that, okay, what we are taking to EPAM from that whole learning, right? And that's where we came up with this prospective accelerators, which can be used with other customer, right? So throughout this implementation, what we realized that there are many pipeline which can be templatized, right, or can be parameterized just by the data, by the configuration and all, and then we can create those pipeline well in advance, right? So even if we start the implementation of any product or any platform, we can very well design and develop those parameterized pipeline well in advance. And as the data coming in, as the configuration of the model, configuration of the prompt coming in, we can just make it more configurable, right? Or I can call it as a configurable agent, right? One of the example is a vectorization, right? So what do you need in the vectorization? You take the data, you embed the data, you store as a vector into any of the vector database. So the vector database configuration could be a parameter. Your data is a parameter, but the rest of the thing of taking the data, converting into particular vectors through the embedding, all can be developed well in advance. So one is the we can accelerate any other customer's implementation through this accelerator. There is another part is like, as we integrate prompt management with the RAG model validation and all, right? We can very well give that kind of pre-built pipeline to other customer in terms of their prompt management and the versioning, as well as doing this vectorization, retrieval, and the search, right? So basically adding the prompt management and the versioning to the whole RAG implementation. Very important part when somebody develop their GenAI platform, they definitely want to understand how the platform is doing in terms of the health of the platform, right? In terms of any security risk, any network risk, in terms of if there is any breach in the endpoint, like if they created some private or public endpoint, then or they whitelisted any IPs and all, if there is any loophole into it. We used a security and risk analysis tool there, which is open source from Databricks, and we used it to kind of get the platform health. And there is a very nice dashboard that we created out of it, which shows that, okay, you're not hitting to any risk and your platform health is good. The last and not the least, but very important part is like, when you build all of these things, right, you need to charge back to the customer, right, or the end users whom you're offering this particular platform. And that's where we use the FinOps calculation framework, which calculate the cost of the model usage, cost of the DBU or the CPU usage, and the memory and the computation, everything, right? So there is a consolidated FinOps reporting that come out of as a FinOps reporting. So you can rightly charge to the user or the customer along with your license cost of any other tool if they are using it. So all in all, these accelerator will eventually help EPAM to kind of serve to their other customer if we develop and design it in a right way, right? So that's all, Volga. Now I think I'm done with all the technical part of this implementation. Yeah.
Thanks, Manish, for the very, very exciting overview of the technical part. You've done a really great job. I will slightly speed up. I really want to have enough time for the feedback loop and answering all your questions. But let's talk about data. So basically, what I want to convey here is obviously the client had very mature practices in terms of the data analytics when we think about it in a more traditional phase. But what we're trying to unlock with GenAI is basically adding their qualitative analytics to their existing quantitative analytics. And let me look it through the lens of this pyramid. When you are trying to increase the business value out of the data, going through the raw data to very, very top level, which is trying to get the action. So this is where I really feel that where GenAI has a lot of potential, and this is what we're trying to unlock, trying to play in these two areas. So just to provide a very, very fast example, is that if we talk, for example, about the market share data, client has a very, very good capabilities in order to transform the transactional level data that they're getting from various sources, like sales transactions, into knowledge, which is understanding of the market share trends. But then what we want to unlock for the end users is to first of all transform this knowledge into human readable format, so that you're not only looking at the numbers, but you are able to get some sort of summary of what's going on in the market, why it's going that way, and very important thing, and where the highest business value is answer the question, so what? So we do understand the insights of the market, but what should I do with it? And this we're tackling with combining the structured data analysis with unstructured data analysis. Let me start with the structured data analysis. So here it's quite established process. As I said, there is a traditional data analytics platform in the client. So basically, a lot of information is coming from there. So basically, type of information like financial, sales, transactional data, market share data, innovation plans, and many of these. This data is flowing through the established process where you have to approve the data model, where you have to sign the data contract before the data is exposed for consumption parts. In our case, this is Generative application, and we're following the already established processes. When it comes to unstructured data, this is something that is fairly new within the client. And the way it's established right now is that we want to allow marketing business users to upload their unstructured files, their knowledge, and getting the insights on the fly from this data. So just to provide as an example, if I'm looking at my market share performance of my brand, I want to get the structured insights from the structured data, but also I want to be able to upload, for example, some sort of consumer trend analysis by some market research company, and make the Generative application to consider this information as well and include this in the analysis. So where the challenge comes is how do we manage this unstructured data? Because it's quite easy to get into the state where it's not understandable what the data is in the platform. How do we make sure that the data is stacked properly so that the LLM is getting navigated to the proper set of information? And how do we make sure that then the proper pipelines are getting triggered based on what kind of data it is? So just to have a bit of a step back, there are two extremes of managing unstructured data. So the first one is not governing the data at all, and the second one is full governance control. When we talk about non-governance at all, basically people upload what they want when they want, without proper tagging and proper control of what the data is in the platform. It provides very fast access to the data, but then long term, the quality of the data will decrease a lot. When we talk about the data full governance and control, it's basically we can hire a team who will check each and every file, make sure it's properly tagged, make sure that there is no data duplication, proper versioning, all of this. But this approach, it leads for very good data quality, but it's not a cheap one. And this approach increases the time to insights, because you have to between you upload the data and you can get the insights, there is a process going on. So we managing unstructured data is not a new problem with an EPAM, and we do have our internal pre-sales portal. So I decided to talk to these guys and understand how they manage the unstructured data. So just a quick introduction, Pre-Sales Portal is a huge knowledge base that exists over 15 years already, and they've been collecting lots of proposals that EPAM does for their clients like over many years. So how their unstructured data is currently managed is that they enforce a very strict SharePoint folder structure where you can get metadata from the names of the folders. And then each document is eventually linked to the CRM system where there is a lot of metadata stored about this document. So you can understand the business unit, if I'm practice involved into the proposal, location, people responsible, many other. On top of that, of course, we're generating some sort of system tags, which is typical document name, author, when created, when updated, all of this. There's also some sort of ML code specification on top of this. And this, so what I want to convey here is that there is a lot of metadata being collected for a single document with very minimal manual intervention. And then on top of this, for a selected set of data, there is a team who is doing some manual tagging and making certification of the document. So then in the very end, you are ending up with findable, reliable information that you can find on the portal. I'm pretty sure that within EPAM, lots of people are using this portal. But getting back to our problem, can we apply some of this? The answer is maybe. And we do have some sort of early view on how the unstructured data lifecycle can look like. Our key difference is that the end consumer behavior is quite different, because we assume that the users will upload their data on the fly rather than storing it somewhere in SharePoint or offline and get sent by the portal. So our early view is that we do allow the users to provide lots of metadata through the UI, because again, the data is fragmented right now. They get the data from various sources like data providers, web portals, personal SharePoints, centralized SharePoints, and others. So yeah, a lot of metadata will be captured through the business inputs, and then the data will go through its life cycle, and then it will be retrieved based again on what end user thinks is relevant. But this is an early view. We're still working on this, and what I want to highlight in this particular presentation is that I've been talking to quite a few people within EPAM in order to understand their thinking regarding this problem and how this can be managed. So if you do have any vision, ideas, experience, I'm still collecting this, please do reach out to me. I will be sharing my contact information at the very end of the presentation. So that's it on a key part. Manish, if you want to very quickly wrap it up.
Sure. Yeah. So if you learn something from this presentation, and if you are aspiring to create the similar platform or any other Gen AI platform, few of the topics or the points which I want to kind of highlight to you, which we did as a lesson learned documentation, right? So as we develop or anyone develop a Gen AI platform, and as we build the knowledge base through unstructured data, the unstructured data management and the governance is very important, which Volga was highlighting, and she spent good amount of time explaining that. So we need to be very mindful, because most of the time the company does have their own data governance for the structured data, but you hardly find any companies or any implementation where you have the unstructured data management and governance. So that's very important. The legal agreement, right? Now, there are many data providers, as we called out in the start of the presentation, there are data coming from the multiple data providers to this platform. We need to make sure that, okay, we need to have a legal agreement with that, right? Because any small information, because once that data has been kind of explained and exposed through the model, through the LLM model, it will have further enriched information, which eventually kind of expose the company's information and a lot of other things, right? So we need to have those legal agreement clearly and precisely draft with those data provider. Model evaluation strategy, that's another part, right? So every model will get kind of upgraded eventually. Like when we started this platform development, we started with OpenAI Turbo 3.5, and then we eventually now using the 4.0 model, right? So we need to have the proper evaluation strategy that, okay, how that model from one version to another version get evaluated, and then also the evaluation within itself, right? That how you are checking the groundness check, how you are validating the output and all of those things, right? The another important part is the human in loop, right? As we talk a lot about AI, as we talk a lot about Gen AI part, but at the same time, we need to make sure that, okay, the human are in the loop at the right time, at the right place. Ease of expansion, as like that's the key for this whole platform. As we are moving from Gen AI to the compound AI, we are moving from RAG implementation to the agentic implementation, right? We need to make sure that the architecture, the approach that we define should be adaptable to these expansions, right? There are many tools that are coming into the market in Gen AI not every month, but every day, every hour, right? And we need to make sure that, okay, the platform is acceptable for or the scaled enough for those changes. Now, if you all put together all of these things, the things will not get fly until you have a right orchestration and ops model, right? And that's where the orchestration and ops model is the key for the production implementation, because things go very well into the dev in the POC environment and all. But as you move everything into the production, the org and ops is very important to take care of it. So with this 6 point, I want to highlight that if you are aspiring and planning to build a Gen AI platform, especially within the enterprise, then you need to be kind of very mindful on all of these 6 points. With that, I'll close. I think we should close the presentation and open for the QA.
Yeah, thank you very much, everyone. We are having our contact information here. If any unanswered questions, please reach out to us. But yeah, open to the questions.
Thank you, Manish. Thank you, Olga, for such insightful presentation, first of all. And yes, we have a couple of questions in the chat, and we would love to hear your thoughts on this. First one, actually, how has this platform impacted the operational efficiency or customer engagement metrics for the client?
That's
okay.
Yeah, let me take that question. So that's very important part. So getting the different application and the product team or the user basically on this platform is a very important aspect of it, and that's where the collaboration with the different teams which are going to get onboarded on this platform is very important at the start of the program, right? So when you start developing the component on this platform and you start envisioning the roadmap, the future roadmap, the collaboration with the different stakeholders from the business side, from the different product or the application sides are very important, because they are the guys who are going to use this platform, right? So just to answer precisely on that question, that collaboration still need to be required at the very early stage of the implementation, or I would say the ideation. And that's the key.
Thank you, Manish. Okay, and we have a second one. I believe you already answered for that, but still, what is your approach to use together structured and unstructured data?
Yeah, I think this was covered basically, but thank you very much. Very good question, first of all. Yeah, it was covered, I think, in the presentation in very good detail. But yeah, in a very nutshell, the structured data management, we relied on the existing processes and set up within the client. When it comes to the unstructured, this is something that we had to ideate during the course of our project. So yeah, basically what we are trying to deep dive into is how do we properly manage the tagging of this information, and how do we ensure that no PII captured in this unstructured data and the data sensitivity classification is properly tagged to the files. So this is something that we are working on right now, but yeah, happy to expand on any particular point.
Okay, thank you, Volga. Great. Once again, thank you very much for your time and valuable talk today. And let's continue. Next up, we have Michael Gaunt with the topic Enhancing SDLS planning and among other application with their Belbin prompt. Hi, Michael.
Hi, great. And thank you for the opportunity to present today. So it is great. So this is work I did across 2 clients, and I did a full analysis to verify the conclusions that I've reached. And let me explain who I am before we start. My name is Michael Gaunt. I work as an analytics consultant at EPAM, and I spent 2 decades leading to tenured professor at the London School of Hygiene and Tropical Medicine. So my background is biomedical. And what we want to address today is this area called a mysterious Belbin prompt and novel approaches to prompt engineering, which I'll explain. Now, the technical term for this talk will be trigger prompts enhanced zero prompting. So let me go through what zero prompting means in prompt engineering. So in an audience like this, I'm sure we'll be familiar with the idea that if we go on to GPT, we will submit a query. That's our prompt. And how that prompt is designed will greatly affect the result that we get. And within this talk, I want to address the issue of advanced prompt engineering. I've called them trigger prompts, and I'll explain that shortly. In the first section, I want to do it to solve a common GenAI training exercise. So a lot of this work does stem from giving training to clients. In section 2, I want to look at interrogating GPT for Omni to summarize complex data. And in section 3, I want to identify choke points in the software development cycle, and this is by far the most complex area. So we want to cover what is zero-shot prompting. You do know the answer, just to make it clear. A zero-shot prompt is a prompt query that lacks an example. So identify and list all the biomarkers of prostate cancer. That is a very confusing statement, and likewise GPT can be confused by that statement. A single-shot prompt is a query. Well, a single-shot prompt is a query with one example, a very clear example. So we have the same example as above. This very confusing statement: prostate cancer, biomarkers, and then we explain a biomarker is a bioorganic compound indicating a hidden current or a future risk of cancer. And here's the example: prostate specific antigen, PSA. A few shot prompt is where we start putting multiple examples into the prompt. And the reason this is important is work done by Phoenix and Taylor, described in Prompt Engineering for Generative AI in O'Reilly Media, 2024. So here in their graph, they have accuracy. Across here, we have different large language models, LLMs. This one over here is almost certainly GPT-3. And across here, we have the number of examples that we're firing. So they're firing a query and looking at the percentage of accuracy of the response. If they don't provide any examples, number of examples, they provide no examples, that's a zero-shot prompt, and the accuracy of that is very low, 10%. As soon as you have a single example, the accuracy jumps to nearly 50%. And then that gradually rises with the increasing number of examples. Now, that's all very well, but zero-shot prompting is often unavoidable. Yeah, and we often don't know what examples to give to the LLM. So to address that problem, that's why I put the zero-shot prompting here. We had the idea of trigger prompts. So this is my term. It's not an official term. I just find it convenient to explain this. This is a prompt. A trigger prompt is a prompt that has a large improvement on accuracy and reliability on GPT's response. And I should add to that definition, without giving it an example. Okay, so that is really important part of the definition. Now, for many of us who do prompt engineering, we will be familiar with the first one. This is a famous one. It's called chain of thought, and it affects the way the LLM, in this case GPT, analyzes and responds to the question, to the query. And all you do in your prompt is you just include the word step by step. This was present in Phoenix and Taylor, O'Reilly Media, and that triggers a completely different process within, in this case, ChatGPT, and that affects your result. Another well-known trigger prompt or another well-known process is called tree of thought. And the trigger prompt here, the key phrase, is simply use a tree of thought. That's my trigger prompt in this talk. Now, a lot of people have put a lot of work into this area, and they were trying to reproduce this area called a tree of thought. And if you go to GitHub or numerous YouTube videos, you'll see complex meta prompts, and they try to simulate a three-person or three or more person stakeholder committee to resolve the question according to this method called tree of thought. We're not going to go through how the methods work. Now, I've tried this process extensively, and it didn't give satisfactory results. So in this talk, I won't go into these methods, and they conflict with a process called iteration, which I use extensively in this work. But then in the committee prompts, there is a Belbin prompt, and I'm going to explain that after my next example I'm going to give. Okay. Finally, there are what I call the knowledge prompts. And in O'Reilly's prompt engineering for generative AI, Phoenix and Taylor described a knowledge prompt saying that all you have to do in your prompt is just say with incredible detail, and that will trigger the LLM to give a lot more detail about the problem. In this talk, I'm going to introduce the idea of a tree of knowledge and give explanations for this. So in your prompt, you write your prompt and you just say solve with a tree of knowledge. And that will trigger a completely different response from the LLM. So I'm going to go through this as a typical Gen AI training scenario. It looks very complicated that a client would have. This exact example has not been given to any client, but it's a typical scenario. And in any sort of Gen AI training, this is very similar to the sort of problems we set. So you set a problem. In this case, we ask the question, where is the developer's lost notebook? And the context of this is that the notebook contains company passwords. So that generally violates company policy, but we don't tell the LLM, we don't necessarily tell the LLM that. And the idea in this scenario is very typical, is the developer starts at home. In the morning, they pack their backpack, including the orange notebook, which contains all the company passwords, together with their sports equipment. They then go to the subway station. They go to the office, have some meetings, notice their backpack is broken, so possibly where the notebook could be lost. The individual then goes to play badminton over lunch. In the sports hall, they turn their backpack upside down in a hurry to get their kit out. They go back to the office and they notice their book of passwords is missing. That's a security breach, and then they report that the notebook is gone. Okay, now it doesn't really matter how complex this scenario is. The solution to the problem is, like I think all of us will know here, is we feed all this into the Gen AI, is the solution to the problem is the notebook should never have existed. There's been a security breach. And Gen AI then will then look at that problem over a variety of different, what I'm calling trigger prompts. So let's have a look at the answer here. So this is the trigger prompt comparison for lost notebook scenario. So this is the Belbin prompt, which I'm about to explain what I'm doing here. This is the chain of thought prompt. So this is saying, just saying in the prompt, solve this step by step. So you've got the scenario, solve it step by step. This is tree of thought, same idea, TOT, and this is solving it without any trigger prompt. And the clear thing to notice is that the Belbin prompt, here is the answers. So the answers that it's going to give, and this is over 400 iterations, 100 iterations, 100 iterations, 200 iterations. So the answers are, the notebook is either going to be in the office, subway, badminton court. It doesn't really matter. Some prompts can't make up their mind. Some prompts think it's in the badminton court. The key to this problem is there's been a security breach, and the LLM has to identify that. So here we got computer security, and we also got the thing that the Belbin prompt identified was team morale and worker support. And that's something that I wouldn't have thought of. So here we go. The Belbin prompt gives us an answer, which nothing else gives us. And that's simply due to the trigger prompt. It's simply due to the little key phrase that triggers a different response. So let's just summarize what's happened. The Belbin prompt identifies security issues, and what it's recommending is to change the password, the company passwords, because the accounts have been compromised. You must change your passwords. It also went on to identify emotional factors about team morale and support, as well as it wasn't quite sure where the notebook was located. Now, chain of thought, tree of thought, and no prompt. Failed to identify security issues, no mention of emotional factors, and the location of the notebook was uncertain except for the tree of thought. So the question is, what is this Belbin prompt doing? Because we actually asked GPT, where is the notebook? We didn't say to it, tell us about security, tell us about emotional stuff. We just said, where is the notebook? So this is a prompt I'm using. There's quite a lot of information on this slide, I agree. But this is a prompt. The prompt is simply solve using a Belbin committee with team roles, step by step. That's the basic prompt. Now, you can include a chair's report. And in the demo, I will do this. It just makes the output nicer. Now, the reason this works, let's go through what Belbin is. Belbin is management theory. It was very popular in the 90s, and it uses team roles to obtain a balance of its decision-making process. So it will typically have a plant, an ideas person. It will have an evaluator, an analyzer. It will have a team worker whose focus is morale and support. And then it will have a specialist, an expert. Then it will have a chair and so on. And GPT-4 Omni uses 10 team roles as soon as you mention Belbin committee. And it analyzes a problem from each role. So that's how it's working. So what's happening in this scenario is often 80% of the time, this is 400 iterations. So I've asked it the same question 400 times. The specialist will be a computer expert, a computer security expert. And a team worker will often be someone who's, well, 20% of the time, the team worker will be involved in morale and emotional solutions. So what happens is Belbin sees outside the box, and I'm going to give you a demo of how it's doing, a demo of this. So here we have, very simple, we have, sorry, this is the wrong example, I'm going to here. Okay, so very simply, we have solve using a Belbin committee with team roles, step by step, with the chair's report. Here we have the problem, highlighted here, which I explained in the cartoon. And all we're going to ask is solve the problem using the constraint. Let's click return and see what happens. Okay, so it's now going through the Belbin prompt. It's devising a plan. It's executing the plan. It's reviewing. And it's giving a chair's report. That was not quite the result I wanted. But if we go through, it's not quite the output I wanted, but the result is the same. What I wanted it to show you is all the different team members in interaction in the committee. Now, what it's given us is just the raw output on this iteration. It's defined a problem for us. It's given us the information. It's looking for a solution. It's generating ideas. It's developing a plan, evaluating, executing a plan. And then it's come up with a key idea that after all this thought process, it needs to implement security measures. And that's key to this solution. It will then give us a chair's report. It then tells us, so the chair's report is, we don't really know. Okay, the chair's report is here. The notebook was in the badminton court on this iteration. Other iterations that will be different. To prevent the incident, you need to adopt password manager. So you need to prevent future recurrence by not having that. He also, this example comes up with a useful idea of replacing the broken backpack. I thought that would be obvious, but anyway, he's come up with that as a solution. And then it's ended on the idea of using team morale. So the teamwork collaborative, you utilize each other's strengths to solve the problem efficiently. Okay, so that's the full output. It's not quite what I wanted to show you. Let me see if we can get it working in the way I was really hoping. But the answer is correct regardless of the process it's used. Okay, so here we go. So here it's now going through. Okay, so now you got this is why we call it a trigger prompt, because it's triggered a large amount of output. And now it's gone through a Belbin committee. So here we got the plant. Let's go down here. We got the monitor evaluator. We got the team worker. We've got the specialist. So this specialist, as normal, 80% of the time, it will be security protocols. Then you've got the chair's report, which is extensive. So you've got a complete answer. That's how it's worked. And that's why it was able to get to answers that other prompts couldn't. Okay, so the section 2, and I want to switch focus completely. I do come from a biomedical background. And remind everybody, it is what we call Movember. So this is where we think about men's health. Particularly prostate cancer is a big focus of this month. ChatGPT for Omni has around almost 2 trillion parameters, and it will contain hundreds of prostate cancer biomarkers of varying importance. So let's go through what a biomarker is. A biomarker is a bioorganic compound indicating a hidden, current, or future risk of cancer. For example, prostate-specific antigen. And the prompts, the trigger prompts I'm describing, provide a proof of concept for summarizing complex data. So this data is in here. We want to get it out. So the trigger prompts to summarize GPT-4 database. So the query I'm using is identify and list all biomarkers of prostate cancer. So not a very useful prompt. It's not going to give a, shouldn't really give a great response. And when I use the trigger prompts I described previously, chain of thought, tree of thought, Belbin, even Belbin, and not using any sort of prompt, what they did was, for you guys, it may not be a big deal. For me, from biomedical, it is a big deal. They failed to distinguish between true biomarkers and biomarker genetic variants. Now, that might seem obscure, but what it results in is thousands of lines of junk being spewed onto the screen. So as you're trying to get these biomarkers out, it will hit stuff that is not really a true biomarker. That's what's happening. Now, there's a group of prompts I described called the knowledge prompts. And these were tree of knowledge, I've summarized here as TOK, and incredible detail. So tree of knowledge is what I developed. Incredible detail is what Phoenix and Taylor are recommending in their book, published by O'Reilly. And these two prompts identify the true biomarkers and remove genetic variants. So this is across thousands of iterations, so thousands of attempts, it's removing them. And so this now leads to a direct head-to-head assessment of which prompt is better. The tree of knowledge, TOK, or the incredible detail. Okay, so this is the assessment. Each bar represents 1,000 iterations. So this analysis has been done 1,000 times. And this is the number of biomarkers. We can come through in the demo what a biomarker is. The GPT will explain it for us. This is the number of biomarkers recovered. Number of biomarkers. This is the number of categories of the biomarkers. So number of biomarkers is 27 here for the tree of knowledge. Now, on another iteration, another type of response it produces nearly 47. And the number of categories of biomarker it's produced is around 6 or 7. If we go to the incredible detail trigger prompt, we get a different answer. We get a lot fewer biomarkers being produced, and we don't get any categories. So just on the red, orange versus blue, green, the tree of knowledge is successful here. Now, just to explain, I had to put it into the talk because it was a key part of the results. For some reason I don't understand, and I did this on Omni version the 13th of May 2024. The results are in two blocks. There's a biphasic response. Either it gives you 27 or it gives you 47. Similarly, if we go to the incredible detail prompt, so this is a prompt just with the words incredible detail in it, you get these two phases of results, either not many or double the amount. I don't understand the reasons for that, okay? It's just one of the results. What I'm going to do is let's go to the demo to prove this in the demo. So we're now going to go to here. So I'm going to use the latest version of Omni. This is the company GPT LLM interface. I'm simply going to ask, identify and list all known biomarkers of prostate cancer. This should be a terrible prompt. Shouldn't really work. Solve using a tree of knowledge. Then I'm just asking, solve the task according to the trigger prompt. Okay, so what could go wrong? Okay, let's have a look. So GPT knows what a tree of knowledge is. Okay. This prompt shouldn't really give a good response, but with this trigger prompt, it's given a very detailed response. And let's see how many biomarkers it gives us. Okay, it's on this query, it's given 7 biomarkers. And it's even given a clear detail about what a tree of knowledge is. So it actually knows what the tree of knowledge is. So I guess it's not really my discovery, it's already there. Tree of knowledge provides a structured overview of various biomarkers associated with prostate cancer. The categories represent different aspects of biomedical research, biomarker research, from traditional biomarkers like PSA to emerging genetic markers and molecular markers. Okay, so it's a comprehensive overview. So we just go through some of these answers. So I said, so PSA is one of the biomarkers. And here it gives the complete breakdown into what PSA is. It gives us biomarkers, total PSA, free PSA, PSA velocity. It's a very comprehensive response. If we go into the more complex areas, hereditary, these are the mutations associated with prostate cancer. Okay, so prostate cancer antigen. This is not normally a category I'm familiar with. Urinary. That shouldn't really have come up here. But we would probably describe these as protein biomarkers. Tissue biomarkers, and we get circulating tumor biomarkers. So it's a complete response. Now, the protein biomarkers, it's given us protein biomarkers, but anyway, we'll skip over this. And then also very emerging biomarkers, microRNAs are very fashionable areas of biomarkers. So it's a great response. And that has simply been a result of nothing more than the trigger. And that is simply, you said to it, use a tree of knowledge. Okay, so these are pretty powerful features. And for the last 20 minutes of the talk, I'm going to go through one of the projects I was involved in, and this is a pretty complex architecture for what we call legal redlining. So we'll have to spend some time explaining this architecture. I realize that in the talk today, this is a pretty common area of subject matter. And what we were doing is comparing legal compliance documents for changes. So typically what you would have in our work is you would have an old version of a document and a new version of a document. These are complex documents. These documents can be up to 20,000 words. And the differences can be subtle. And what you want is an application, an architecture that can pick out those differences for you. And that application is generative AI. And what you get is you get the two versions of the compliance documents are either PDF or web. They get ingested. That triggers a response to our messaging system, RabbitMQ, which notifies our scraping and pre-processing unit. It dumps the document into MongoDB. The scraper, pre-processor gets the message, comes back, gets the documents, processes them, and sends them back to MongoDB. Then this scraping unit sends a message to our messaging system, RabbitMQ, and informs it the documents are done. You want to now message the GenAI analysis. The GenAI analysis now gets a message, documents are pre-processed, I need to analyze them. It picks them up from MongoDB, takes them back, analyzes them, puts them back into MongoDB, and then that's saved in MongoDB until the user interrogates that database. That's how the architecture works. And the choke points that we're going to be identifying today are locked within the GenAI unit, which obviously that's a bit that I do. And what we do is we take this whole architecture, we put it into words, we take all this information here, including the idea that the token limit issue is suspected. So what that simply means is that the documents are too big to get into generative AI. GenAI will not process them. Okay, so there's too many tokens. And here we could use it as a synonym for words. It's just going to say no. And we put that into GenAI, and then we ask GenAI, what are the choke points? So let's go through what a choke point is. So this is really important, particularly in consultancy. And this is why I developed this solution. It was partly a client request for a previous client. But a choke point in time-pressured consultancy is not good because it's restricting development time. So in this particular scenario, the real-world choke point in large document analysis, this is not large language model analysis. This is using large language models to analyze large documents. In my experience, this is called lost in the middle. And this is where the large language model, say GPT, starts to analyze a document. It looks at the beginning of a large document, it looks at the end of one, and it omits all other areas. The token count is often not exceeded. So if the token count is exceeded, the GPT, for example, will just refuse to do the analysis. But the error will still, but it will help, it will persist the error, it will help trigger the error. So lost in the middle error and document redlining. So when you're comparing two documents, legal documents for small changes, it's called redlining. If we put two 50-page PDFs of compliance documents into the LLM, the Gen AI, it should yield 300 identifiable differences plus. So the old version versus the new version should be a lot of differences. Actually, what we observe is only 7 differences. So there's been a catastrophic failure. And fixing these bugs can take time. Just to note, this information was not put into the prompt, so we've not given GPT this information. So in the real world solutions, I didn't use GPT to solve it. What I used is document partitioning and chunking. So this is where you take the two documents, you split them, divide them, chunk them, section them. There's lots of ways to do it. Then something called sliding window analysis. Now from biomedical, we like these solutions. You don't have to worry about it. Then there's the issue of token management, compression, and reduction. And this information was not supplied to the prompt. So what we now want to see what the trigger prompts recommend. So I'm asking it, I'm giving it all this information, and I'm saying, where are the choke points? You tell me where the choke points are. Now it's important in this query, I informed GPT, these are large documents, 20,000 words. And there are token limit concerns. Now this, in some ways, could be an issue because I've informed it partly what the answer might be. So if you look at the trigger prompts, here's none. Here's chain of thought, tree of knowledge, Belbin, and tree of thought. Okay. 100% of the time, this is over 500 iterations. So this is a lot of requests. For none, it says it's token management or lost in the middle. For tree of knowledge, it says exactly the same. For tree of thought, it says exactly the same. It's 100% for all iterations. Where are the problems? Now, there could be many problems in this pipeline. Let's just be clear about this, where the problems could be. The problems, the choke points could be anywhere. However, it has picked out the choke points are just with this phenomenon that I've described to you. We have passed on to it. Token limit is a concern. And when we get to the Belbin prompt, this really got me sold on the whole idea, really. Because the Belbin prompt disagreed with the whole idea that it was singly about token management or lost in the middle. What it said was, well, a lot of the time you're going to get data issues. And when I did this talk, I thought that's a rubbish result. Why is that there? And then I thought back to the project and I realized, yeah, I know what it's getting at. I went through the output. And then I said, yeah, we had that problem in the project. We had that exact problem. So what it's referring to is when you're dealing with compliance documents, and this is not in the talk because I thought it was a null result. When you get compliance documents, what happens is that they're in very varied formats, and that's critical to processing. So pre-processing is not trivial in these things because you can get compliance documents just loaded full of tables. So just tables upon tables. And pre-processing is and in PDF, that can be hard to extract and you can't make any mistakes. These are legal documents. You can get multiple columns, like I think the HIPAA document, the health compliance for the USA document, that has a 3-column format. And that again is not trivial to process. So a lot of time goes into managing the data. And that's what the response was telling me. I went through the raw output and that's what it was telling me. The other issues, integration, optimization, performance, none of them really saw it as a big issue. But what was curious is it got the right answer when none of that answer was actually in the request I made to the GPT. And that's typical about the way the Belbin prompt responds. It thinks outside the box. Now let's just take the key example. So what we're looking for is all of the outputs. I want to know, okay, so you've identified the choke point for this section here, token and lost in the middle stuff. You've got the choke point. I want to say what you're recommending that I do to solve it. And if we look over 500 iterations, the responses are varied about what it thinks you should do. Over here, no trigger prompt, chain of thought, tree of thought, Belbin, and no, tree of knowledge and tree of thought. So chain of thought, here's a different solutions. Document chunking, this is the one that I would strongly favor. Document partition and document chunking are the ones that give the answers in from my experience. Sliding window analysis, this is very cool. I like it. We won't go into it, but it does work. I got it working. Hierarchical partitioning and token management. So they give different responses over the 500 queries. Okay. Chain of thought think it's just about managing the tokens. Now that's not true. That's definitely not true from my experience anyway. Belbin is quite good. There seems to be a balance here. Tree of thought, there seems to be a balance between document chunking and token management. Now let's just take a look. These are 500. We've asked the thing the same question 500 times. Let's look at the top 5 recommendations because those are different. So when we see the top 5 recommendations in a GPT, we get a different set of results. And actually these results are really interesting. They're very similar to each other. No matter what prompt we use, none, chain of thought, tree of knowledge, Belbin, or tree of thought, they're pretty similar. They're saying it's a combination of document chunking and token management, document chunking, token management. So that's an interesting output. That in this scenario, in this particular scenario, there isn't actually one fixed prompt that undisputedly works. Now, I tended to favor this one as my answer, but that's just because the bias in which I used to solve the problem. I used a combination of chunking and partitioning, and one of the solutions was sliding windows. So I tended to like this response, but it's not the key response that these LLMs are coming out with. It's saying it's a balance. Okay, so these trigger prompts produce different results in summary. The Belbin prompt maintains an out-of-the-box view that token management or lost-in-the-middle solutions were only the top choke point 65% of the time, and it suggested there were data issues. When I went through that in detail, that was absolutely correct. There were definitely data issues in that project. And again, that is simply how you format complex PDFs and how different compliance documents use drastically different layouts. And you have to capture all of those in your pre-processing of the document. So let's just flip back and just explain. So that's this graph here. We've asked it, what are the choke points? Belbin has said, 65% of the time, it's token management, lost in the middle solutions, but 20%, 25% of the time, it's about data issues. None of the other prompts have identified that. And I was quite impressed by that. When we look at the top 5 recommendations for solving the choke point, they were all similar, including not issuing a trigger prompt at all. And this was a balance between chunking or segmentation and token management. Now, as soon as we pass the first 5 top recommendations for each LLM, this was replicated 5 times, so there's 25 recommendations essentially. the responses tend to diverge and give very different results. And all the trigger prompts did that. One thing that I've not shown, although technically I do have time to show it, but we'll not go into it, is that under the non-prompt, when you don't issue a trigger prompt, what you're doing behind the scenes, what the LLM is doing, is it's giving you recommendations for the libraries you need to solve the problem. I've not reported that here, but normally it will give you 4 libraries to how to solve this problem. So here's the choke point. Here's how I would solve the problem. So here's a choke point. Here's how I would solve the problem. These are recommendations. What I've not shown you is the software recommendations, the libraries it would say to solve those particular problems. But when you did this if you didn't put a trigger prompt in, it grossly underreported the libraries you needed to solve the problem. So there is a problem if you use a zero trigger prompts. Okay, so I was quite impressed by what was a really complex scenario, that the Belbin prompt succeeded in that scenario. So what I'm going to do is just summarize the whole area of what I call trigger prompts. So again, trigger prompts, I'm saying, are prompts that are very few key phrases that produce a very big difference on the GPT's output. And in section 1, we had the problem solving of the developer's notebook, and Belbin won hands down. There was no competitor. In section 2, the tree of knowledge won in data summarization. We'll come back to this in a minute. In section 3, all prompts had merit. And what I mean by that is this graph here. These, whatever prompt you're using, it's a pretty similar solution. These are recommendations to solve the problem. All prompts had merit. But the Belbin prompt correctly identified 2 true choke points. And when I look back at the project, those were absolutely the 2 choke points that the project faced. And this is in the software development lifecycle. So the really strange thing about the Belbin prompt is that and what really surprised me was section 3, the answer from section 3, because I was not interested in that answer. I did not want to know that answer. I'd already solved it. It wasn't a problem for the project, but Belbin came back with it. That was a choke point. And it appears to be able to override a single shot or a few shot prompt. So what I'm doing in section 3 is I'm telling it, I think there's a problem with the token limit. I think you're going to exceed the token limit. And all the other LLMs fell for that and said, yeah, that means that's the choke point. The LLM seemed to be able to override it. So in a sense, I'm giving it an example of what I am expecting. That's the problem here. Belbin overrode that completely. And that was impressive. What I've not gone through in this talk is I've not explained the techniques used in iteration, and those are very complex. So a lot of the time what I'm doing is I'm getting the LLM to iterate itself. And that is not easy to do. And one of the issues about tree of knowledge that's very nice, that's not really presented here, is it will iterate really nicely. So you set up a situation where you say, iterate this over 1,000 times, away it will go, and tree of knowledge will simply do it for you. You have to put in safeguards to prevent it from looking at the last answer to influence the current answer. But it's really cool at doing that. But we have not gone into iteration at all in this talk. So thank you very much. I just summarized the key concepts in this talk, and those are just 2 basic, very simple words that we can use in our prompt engineering. And that is simply introduce a term, solve using a Belbin committee with team roles step by step. You can include with the chair's report if you want, but it can be left out. And the other prompt I put forward is solve using a tree of knowledge. And I think we can agree from this talk that produced very dramatic, unexpected output, which surprised even me, and I designed the prompts. So all in all, All in all, I was impressed by the power of these trigger prompts, and that's why I'm recommending them to you today. So thank you for your attention.
Thank you very much, Michael, for this insightful and smooth presentation. We have one question in the chat. Did you consider any prompts fine-tuning approach?
Right, that's a great question. So fine-tuning using using a RAG. A RAG is essentially a multi-shot prompt. That's how RAG works. And yeah, sure, I've done RAG solutions, and what you're going to do is you're going to send in your RAG query. It's going to pull out documentation, put it into your prompt, and send that as like an example into the LLM, into GPT. And in the legal compliance work we were doing, a RAG would have been an excellent solution to the lost in the middle. It would have solved a lot of issues. In this particular example, when I came onto the team, they had not gone down the RAG approach. So to meet the deadline, we didn't use RAG as that particular solution. I am aware how powerful RAG is. And what I would simply point out is that the trigger prompts I'm presenting today are an alternative way to RAG. RAG is a formal solution to how you generate examples, and that's what they basically are. These are multi-shot prompts that will go into your LLM. The trigger prompts I'm presenting are a way to bypass that process. So yeah, I understand the question. My answer simply is that under the time pressure, the team didn't develop RAG. RAG would have been not a bad solution. There would have been other issues. There would have still been choke points. The choke points would still remain how you process the documents, and particularly how the RAG processes those documents, because that can be a big issue. So if there's an error in the processing, document processing, and you put that into the RAG, that's fairly disastrous. That will give you the wrong answer. If you just take the documents together, there's an error in the pre-processing, and just put chunks into the LLM, you can get away with that because the GPT or the LLM allows you to overcome those sort of small errors. But if they've gone through a RAG, you recovered them from a RAG, you put them into the GPT, that's when things can really go wrong. So a RAG is not a bad solution. It's not a perfect solution. I'm aware, I know how to implement them. They will be regarded as a multi-shot prompt. And in this case, we didn't do them. Great.
Thank you very much. Great answer. And we have another question. Do you think it's effective to update the RAG status daily, or does it become too costly and time-consuming for businesses?
Whoa, that's a big question. I mean, a lot of my expertise is in, my approach to RAG has been through Databricks. And in Databricks, one of the big issues is cost per se. The cost of using Databricks is expensive. And I mean, clearly in legal work, I would argue that the cost isn't an issue. It's not like you're doing a public facing RAG. So it depends on the context. So in legal work, when you're looking at compliance documents, it's costly for the legal department to send someone, it's costly for someone in the compliance department to send someone and legally and go through those two documents, and that person can make mistakes. It's better to give that over to the GPT. And the legal department, it doesn't matter how much it's going to cost them, because what they want is accuracy. And their staff time is expensive. So cost is not an issue there. But when you've got, for example, a public facing RAG, which I've not worked on, I've got to be clear, then cost can definitely be an issue. So when you're updating a RAG daily, I mean, that's what RAG is about, up-to-date current information, and it's going to depend on your context. In the particular architecture I presented, it would only update when there was a new revision of a compliance document. That's the prompt. That was a trigger for which you would then ingest the document. Generally with RAG, if you've got a public-facing RAG in areas that I've not worked in, a routine, regular update is what RAG is all about. It's about keeping your knowledge current. Now, in this context, the RAG is not being used. In the example I presented you with, like in the first example, the first question was about, you can solve this using RAG, and I agree 100%, you can do. So it depends on the question you're asking. So I wouldn't see RAG updating as being a cost issue personally, but I've not worked on public-facing LLMs where you've got a chatbot and the data needs to be updated and cost is an issue. Yeah, that's not my area. I'm sorry.
There is update from the author of the last question. I mean, if it makes sense for products that require often updates, like Newsbot.
Yeah.
So I guess it's better to use GPT. This is
you want to
part of the question.
Now, well, okay. So in legal work, so this is about cost again. So in legal work, I would say that the latest GPT is essential because for them, cost is not an issue and accuracy is a big issue for them. So the very latest GPT is an issue. When you're doing chatbots, then cost becomes an issue because then you can move into the free LLMs such as Mixtral or Llama. Databricks has DB-Rex. And then you start having the complex issue of balancing the accuracy of the response, which you then monitor, say with Blue and Rioux with metrics, versus the response time versus the cost. And I'm familiar with those areas. The issue really is that in legal work, you don't touch on that area because you want the biggest and the best, and the cost is not an issue. And I fully sympathize with the situation where you have to balance the three parameters. You have to look at your response time. You have to look at your model. The only advantage in those situations is that you can have, say, you can use a low parameter model, such as Llama, and you can train its accuracy against a high parameter model, such as GPT. So you can do automated training to look for the accuracy of your model, and particularly if your model doing fine tuning and RAG against a really powerful model like GPT. So I definitely get that you're in a situation where cost counts, GPT is expensive, RAG can be expensive. So I understand it's not quite the scenarios I've come at this. It's not, yeah, these are not the case studies I've personally worked on.
Thank you. And please choose which question you liked more. The first one about prompt fine-tuning, or the second one about RAG status. And this person can win 1 year premium LinkedIn subscription.
Okay, I would say RAG is very trendy. So I would go for the RAG fine-tuning. Although there was a misunderstanding in the question, it is still a very fashionable area of LLMs. It's very up to date. And if you're working on RAG fine-tuning, yeah, I wish you all the best.
Thank you very much. Andre, I'll send email in the chat. I'll try to do it now. I'll do it in several minutes. I'll send an email and please contact Maria and you'll get subscription to LinkedIn Premium. Okay, thank you very much, Michael. Please, yeah, dear guests, please join our next talk in 9 minutes. Efficient inventory management using AI and optimization. The next topic. Thank you. Our next session, efficient inventory management using AI and optimization. Our speaker, Silva, is lead data scientist at the PAM, and he'll uncover how the fusion of AI and advanced optimization techniques is setting new standards for inventory management practices. Dear guests, feel free to type your questions in the chat during the talk. The person who asks the best question will win 1 year LinkedIn Premium subscription. Silva, the stage is yours.
Thank you. Thank you, Victoria. Can you hear me well?
Yeah.
Okay.
Everything's fine.
So let's start. Right. So thank you, everyone. And I've come here today to talk about the inventory management. During this presentation, I'll dive into the story that we start this path, right? So that we start from an idea, how we could help our clients with inventory management using machine learning and optimization techniques. This idea, it's a new revolution for inventory management and go beyond the traditional limited systems that deal with very outdated methods. The objective here is to demonstrate how this technology can be used strategically for the companies in order to ensure most effective stock levels, reducing costs in general, enhance the overall efficiency without reducing the customer satisfaction. This integrated approach not only addressed the inefficiencies of the past systems, but also set a new standard for the future. And so I invite you to join me on our journey here and understand more how our thought process was. So the presentation will be divided in 6 parts, right? So I first have to tell you a little bit of background that I'm coming from. I'm coming from decision optimization background, what is about, right? So how we think about solutions and what's the kind of techniques we use for those. Then I will do a brief introduction of inventory problem, right? So how this problem came to us and how multiple of our customers are having issues with inventory right now. Then I present our approach, right? So how we think different from previous approach and how we think that we can modernize the current inventory management using that approach. I'll show a quick demo that we construct for precise activities. And then I finish with the use case that can show a little bit how we are able to save, we're expecting to save millions with this current approach. What's our vision for the future? And also we'll finish with the Q&A. Okay. So let's start with just a quick introduction so you know who am I, right? So to understand a little bit how we think during this process, you also understand, I need to understand a little bit of my background. So I'm lead data science here at the PAM. I'm the head of the optimization offering. I come from a background on IT and both data science, right? So, and I work with several companies and started my journey with data science 2007, right? So with sentiment analysis. After that, I did my master and my PhD with both merging the machine learning models and optimization models. And I'm specialized on impact. So the things that I like to see is KPI, how you change the decisions, how you save money for that company. And I have done this for several industries like CGP, gas and oil and gas, energy, financial, pharma, and several others. Right. So, and here at IPAM, I'm also responsible for the optimization practice. So let's start with decision optimization, right? So decision optimization is all about the process, how you model a decision, how you model what sometimes is just on people's mind to be able to get the best choice under given assumptions. Those given assumptions can be constraints, can be limitations that you have to the process, but you have to understand what's the process that you're constructing, right? So what's the process that you're going through, right? So and then you transform this into a data-driven decision model, right? A lot of cases, for example, we're going to use mathematical construction of this reality with a goal function, with constraints, and bring all that reality to a process, to a model that can actually optimize and get the optimal decisions based on the assumptions. Right, and that's my background, right? So my background is on decision optimization and machine learning as well. So that's where we begin the path. But what kind of applications we can do it with decision optimization, right? So there are many, right? So decision optimization has been used for like years and several industries. So for example, if you think about oil and gas, the way that they will use and maximize the oil and gas extraction is during the optimization process, right? So how can extract the most oil given the constraints that they have on the platform? Healthcare, telecom, where you put like your towers, right? So where you decide to put your towers is a very important strategic decision process, right? So you use optimization for that. Transportation, routing of your transportation, how many trucks you should have, how you go from like last mile, middle mile, all this is done through optimization. Energy generation is also like energy as a whole is a consumer of optimization, right? So how you distribute that energy, how you change your grid in order to have a better distribution, but as well as how you handle demand fluctuations, right? So and also generation fluctuations to be able to attend the best to your client. So it's spread all over the industry, right? So 85% of the Fortune 500 companies use some kind of mathematical optimization, right? So, and I know that a lot of people don't know about it, but your energy price has some kind of mathematical optimization. The cost of the energy in a lot of countries come directly from optimization model, airline tickets, delivering of your for products in your home, right? So there are several others that are using optimization. So it's all over there. So there is hundreds of applications in the industry using it. And if you think about how we look at the data science, right, as a broad, right, so where this decision optimization process stay, right? So because data science, we talk about a lot of data analytics and also machine learning, but where decision optimization and mathematical model sits, right? So data, it starts with like the data science starts with data, right? So you start to understand the data, you structure this data in a proper way, and then you start having like our data science projects, right? So you start to have descriptive that's telling what happened, right? So if there is some problem on my refinery, or if there is problem on my site, manufacturing site, what happened there, right? So we talk more about the past. We can cite it here like business intelligence, analytics, and others that can help with this. You have diagnostic, so then it's going to tell you why this happened. You have the issue there and why this happened, and you can think about like predictive. Then you start to go more toward machine learning, right? So what could happen in the future if I keep producing like this? What's my expected demand? All this is on the predictive part. And the last gear on this process is actually decisions, right? So and then you become prescriptive, right? So then you're actually suggesting decisions. So for example, if you think about like the CGP companies, you could have like the demand for the forecast for the future, but how you're able to produce like the products in order to achieve that demand is when you get to decisions. And that's the part that has the most value. So you can see in the bottom here that you go from insights all the way to value because of the as you get closer and closer to the decisions, you're going to have more value, right? So if you'll be able to reduce your cost from like $1 to like half of that, then you have a very big implications on the costs. So there is a lot of value when you get closer and closer to decisions. So then what kind of expectation we can have from projects on decision optimization, right? So in reality, we have a lot of numbers, right? So we are one of the streams in data science that can easily get the numbers because we have to get so much close to the decisions that we can actually see what was doing before and seeing how the process changed. And some EDAs cannot allow us to divulgate like specific projects KPIs, but I got a book here. It's a good reference that he does some estimations on calculations on savings for the projects that have been done before, right? So then the short answer is that you can save millions. As again, you saw the other slide, we are getting closer and closer to decisions. The impact is huge, right? So, and we have done projects here internally at IPAM with the same goal and with same results to save millions for our clients. One specific important situation for this context here that's on this book, there is this case from Samsung Electronics that they reduced the manufacturing times and inventory levels, and they save like 200 million. They have 200 million more in revenue. So then you can understand how much this process is important for the company and how much you can save with a process like that. So then you understand about decision optimization. That's my background. That's what I come for. And now I will bring you to the same part that start this journey with the inventory problem. I have know about inventory before, but I never dive on too much detail. So then I start to dive in more and learn more and reading the books about inventory problem. And you can see here in the right, so you're going to see like three main KPIs of the inventory, right? So inventory is all about cash, right? So when you produce something, when you create inventory, you are storing that cash on a product, right? And you invest on that product. What you're doing there is you have more inventory to be able to handle fluctuations on the demand, but that's investment. If you don't have that inventory, you could invest on better manufacturing, better process, hiring people everywhere in the company, right? So getting inventory, getting this cash around, it's an investment. Okay, and the deal will be to have no inventory at all, but then you not be able to attend your demand. So this is the first KPI, cash. Then you have costs. So the cost of producing that product, the cost of holding that inventory, the cost of transportation, the cost of ordering, all the costs that's it's part of the manufacturing process. The cost of staffing, all this has to be considered, right? One of the things also, for example, if you think about cash and cost, you could, instead of having inventory, investing on better machines or better training of the people so your process will be more efficient. So again, the trade-off between those KPIs. And at the bottom, you see service, right? Service is your client, right? So if you go and don't have any inventory at all, who's going to suffer is your client, right? So your client will ask you for some products and you say, oh, I'm not able to achieve your demand. And then you start to have a bad relationship with your client, right? So, and then the client will like find another company or your competitor to be able to get this demand from, right? So, and there is levels, right? So maybe if you don't achieve a little bit, it's okay. But if he asks for like 1 million of this product and you just be able to deliver 10,000, for sure he will like go to your competitor and ask for the rest. But let's dive a little bit more on the details of inventory. What is around, right? So every one of these items here are related to the cash, cost, and service. But let's talk a little bit in more detail. So cost, you can think about like the cash flow that you have, right? So use the interest rate, right? So you cannot only look at your decision on this month, but you have to see the implications of your decisions on next month going forward. So then you have to consider your month sales less the cost, right? So that you have this, right? Variable or fixed costs, staffing costs, and whatever other costs you would have. You have physical constraints on the process, right? So you cannot pick it up and suddenly produce like 10 times more than you produced last month. You don't have enough machine, you don't have manpower, and you have to consider that we are dealing with people, right? So there is constraints. There are people that get sick on the manufacturing process, right? So in the production line, sometimes have to stop because of that. And on this, you have to consider the speed of the product. So you have constraints for this whole process, right? You have lead times. Lead times, it's the amount of time that take for you to make a decision. I will produce 1 million of product A. Then you have to order the components to do it this product A. And then you produce this product A, but also you have to bring this product A all the way to the shelf, right? So to be ready to be sold, right? So you have to consider all this process, right? So from deciding to produce, getting the raw materials, then like produce, and then bring this product to the final client. So all this you have to be considering. You still have supply constraint also together with the other constraints, right? So sometimes you can produce like 1 million, but you cannot deliver that 1 million to the client. Then we also have lost sales. That's a common process to calculate here on the KPIs, right? Stock out cost. Stock out function is quite difficult to model because if you, for example, you lost a little bit of your sales, should be all right? So if you lost 5% of your demand, it's okay. But if you lost half or more, then you're gonna take a lot of money investment on marketing activities to actually recover that amount of money. Okay, so then you have to have something that's non-linear. That as you go and not deliver more percentage of your demand, your cost per unit will be bigger. And you have your inventory levels, minimum, maximum inventory. You cannot store more than 10 million units. You should have sometimes some minimum inventory just to be able to deal with transportation. And then comes like the demand fluctuations, right? So it's the last one, but it's I think on this process is the most important one, right? So demand change. So this every month you see a forecasting, and next month this forecast will change. Depending on the industry, this forecast will change just a little bit. On several industries, this demand fluctuating a lot. So your forecast from one month to the other can change 30, 50%, 90%, depending on the product. So there is a lot of demand fluctuations. And how you deal with these demand fluctuations is quite important. Okay, so this is the inventory problem, right? So given that, what companies will like face as a challenge, right? So they have their own like capabilities. Nowadays, there are softwares out there that can deliver the inventory management, but why what kind of things they fail to deliver, right? So I think the first initial one is that a lot of those softwares, a lot of the solutions, they don't consider demand with fluctuation. And sometimes it can consider, but it will be quite stuffing, right? So they will actually try to have some shock absorption, but something that's not dynamic, that you decide for the whole year, and then realities change. So they have this inability to consider demand fluctuation in the process, not as an external thing that you build up inventory just for demand fluctuation. Models cannot fit what the company requirements. So a lot of cases when you pick it up like out of the box solutions, the company struggle to fit on that process because each company has its own process, its own IP property, right? So it's the way that company is doing that, right? So and differentiate themselves for the other companies also. But when you pick it up the out of box and everyone is using the same, then you have to fit it to like a standard process that's not necessarily your process. And then you see companies fail to fit that or go into like the firefight mode that you do one thing for the software and then you do another thing when you go for the site because it doesn't fit your reality. And this will lead to excess inventory. So a lot of cases we saw from multiple companies that comes to us to asking for help. And so they're doing some ad hoc that they're increasing the forecast, for example, because your CFR, your service like being hit, right? So you're not achieving your demand, and they're doing a lot of like tweaks in order to be able to software to get what they want instead of changing the software because they cannot change the software. So, and there are other things like no capacity, right? So a lot of softwares don't have capacity limits. So then you're choosing two products that have a bigger volume, but they cannot be produced together. Then you have to make some secondary decisions, what prioritize which product to do it. And you have like supply planner like dealing with this, with scheduling considerations and all the constraints that you have with the manufacturing process because those softwares cannot adhere to that. And then you have non-dynamic decisions that you decide once in the beginning of the year, and then you stay with the decision for a whole year, right? So that's not gonna work with today's environment that changed a lot. So in the end, what you have like high inventory, right? So a lot of companies come to us asking to help with this high inventory, low profits because your process has to continuous go through like firefighting process. You don't have like anticipation of what's going to happen. You don't have a proper plan, and things will go as you plan, like on short term. And you have lost efficiency, right? So people are trying to like go through like the products that they were not able to deliver last month and trying to deliver them this month, and you change the plan because of this. So then your efficiency is not as fast. So, and why? Why? So we are seeing this problem over and over in several industries and several manufacturing process. So why this is happening? How? And we have to dive a little bit more on the process, right? So one of the things that when we dive into this industry, right? So this like inventory management process, right? We saw that they're using 1920s mathematical equations. There is one thing called economic order quantity that almost all the companies are using, right? So and this is very old math, right? So the methodology is very old and it doesn't adhere to like today's standards, right? So when this here have on the left like the figure when this equation was invented, and nowadays the manufacturing process, right? So it doesn't fit anymore, and it was because they have a lot of limitations on the what methodology they can use back in 1920s. We don't have this limitation anymore. So this relies on century-old methods like EOQ make the process much harder to do it, rigid. And sometimes when they do it, for example, EPQ cannot handle demand fluctuation. So they will just like do a patch on this process. Then they build safe stock. So then everything starts with this very old methodology. Sometimes they use a little bit something more modern, but it's from like 50 years ago, like 30 years ago. Nothing like on the from the last 30 years. So then what will happen with this legacy approach, right? So why this classical approach fails? Sometimes if you have a good enough approach, that it's so good that they keep using, but not in the case here. This approach did not consider all the costs, right? So there is no sales, there is no profit calculation. It just considers very simple cost of ordering cost and production cost. That's just two costs, right? So there is a lot of other costs there. There is not even like fixed cost or staffing cost. There is no uncertainty at all, right? So on this, you can add it, but it's going to be like a patch, right? So you add saved stock, and then you have saved stock that it will be the same for the whole year, right? So production, sometimes there is even an assumption that production is instantaneous, right? So that you decide to produce this month and it comes next month. So no, you have to consider lead time. One decision for entire period, right? So then you decide at the beginning of the month on the year, right? So and you don't change for the whole year. It's a lot of fluctuation that you can have in your demand, and you have to change the decisions after you see changes on the demand. So you cannot sometimes increase or decrease the production orders, right? So it's fixed the amount. You don't have seasonality. There is no real constraints. This model cannot consider maximum stock capacity, or or there is like some very simple and realistic assumptions, right? So there is no vision of the future, right? So you see your inventory as now, but you don't see that if you produce a lot this month, you have to do, if you produce like 10 times your inventory that you need like 6 months to consume, then this inventory will be with you for 6 months, right? So there is like very like myopic vision of your seeing your inventory just on your month, right? So and products are treated individual, right? So you don't see that if you are producing those two products together, you're not going to have enough capacity for produce them, right? So then they have to like adjust this on the supply planner have to adjust this on like short-term scheduling. So okay, now you understand what we were facing, right? The challenge that we are facing. So here we come and say, okay, so how can we tackle this problem? What's on the core of this issue, right? So our goals with this new approach, right? So our modern approach to inventory optimization. Reduce your inventory by considering uncertainty in the decision process, right? So we're not gonna like escape from this, right? So a lot of those indicators that we're seeing, it's because your demand fluctuates a lot, and you have to integrate these demand fluctuations on your decision process. So you do the optimization on product level monthly, and then you can decide your production on this monthly basis, right? So also one important thing, we have to have simulation capabilities. You have to see if I'm gonna create like my order size, my batch size is gonna be very big. Okay, you're gonna save on like on the production line. Your production line is gonna be more efficient because you're producing the same product over and over for weeks. But what's going to be the implication on inventory? You have to see those three KPIs together. You cannot just go for one and then discard the others. You cannot go for reducing your inventory. I will reduce like 30% of my inventory, but then your service, like your demand, you will not be able to achieve your demand at all, right? So you have to look them together, and you have to have the strategic tools to do simulations and see what's going to be the result of this. And so then you think, oh, this is too good to be true, right? So why we don't have something like that? and why people were not constructing something like this. And the idea is that you really need like a specific set of skills, and you need to join two things here. You need to join like machine learning capabilities to do like very good forecasting, to have like your uncertainty for those products, to have seasonality, a lot of things that we were saying before that we're not able to do it with traditional models. And then you have to have your decision process together with this. You have to have a decision process that can handle uncertainty. So you have to have an optimization model together, right? So, and those two together is that's what's different here from the previous like traditional approach. And what's going to bring it with this, right? So we're going to optimize decisions based on real cost. Include as much as you can the real assumptions to this model. For sure, there will be some limitations, right? So, but you can go much further. I would say like years further if you think about technology here, right? So we can see the future like 24, 18 months ahead. You can do simulations. You can calculate several different costs. You can see your inventory costs, you can calculate stock out, and you can do everything together. So you have several KPIs, and you can bring those KPIs to the future and give optimal decisions with this process. With machine learning, you can do seasonality, you can add the uncertainty and use the uncertainty inside the optimization model. So those together, right? So then if, for example, you see that in the end of the year for this product, you have more uncertainty. So then you're going to build that inventory close to the end of the year. You're not going to build the inventory in January because you possibly could have uncertainty in the end of the year for this product. You're going to build inventory close to it. And if the demand comes high, you have inventory and be able to meet. If the demand comes low, you don't stay with this inventory for the whole year. You stay with this inventory for a short period of time. So you have this dynamic decisions, right? So, and you change then as things change. For sure, you have to consider lead times and you have to have some fixed period, but it's not a year. You do better stock out functions, right? So a lot of case we see like old service level, and it's a very bad metric to measure like sale loss. We have case fill rate, but even better, case fill rate is just like the percentage that you will be able to achieve your demand. But it's not the same thing when you will be able to achieve 95% of demand or half of that. If you achieve half of that, you're really in trouble. You're losing a lot of sales, and it takes a lot of money to compensate for this in the marketing activities. Real assumptions, bring as much constraints as you can, right? So bring it capacity constraint, minimum maximum orders, how much the bat side that you have, right? So everything, and also enable the model to help with this process, right? So if you see that's missing some assumptions and your production is fluctuating a lot, then you can bring something to regularize and help to stabilize this production. And the last one is risk, right? So with this process, bring the metrics that can tell you about risk and what will be the implications, for example, if you reduce your inventory. And that way you can have strategic trade-offs, right? So I'm going to reduce my inventory like in 20, 30%. But then my case fill rate, I'll go from like 99% of my demand 10 to like 97, 96. It's okay. Maybe you're not investing like hundreds of millions on inventory, and you can use for other things. And then you can also think of, oh, we can recover this demand later, right? So it's not that big difference, right? So that's quite important to understand the risk. So, but let me explain a little bit. I give like very bold assumptions here. Let me explain how machine learning and optimization can work together in order to deliver this. Machine learning is the way that we find patterns on data, right? So you make predictions, you give like sentiment analysis, you do classifications. That's what machine learning does. You have to put like a big amount of data, and then it can help you to find if you have like a bad, good sentiment, what's the classification of this, what will be your forecast for like the month next month, right? So, but you must collect the necessary data. You structure this model, train this model, and use in the future and decide also the model quality of this model, right? So then we have optimization, right? So optimization, it goes on the decisions, right? So it's not able to forecast like as machine learning. It's not able to find patterns and data, but you can model the process, right? So you can model constraints, right? So my capacity, it's that amount. I just can do it like 40 shifts on this month. I cannot do more than that. So then that's a limitation, right? So, and we make the decisions based on this mathematical model, right? So, and we can accurately measure and simulate the things for the future. You simulate decisions. Here you can simulate like forecasting demand, but here you're simulating decisions, right? So then you have your decision variables, you have your constraints and your objective, and you have to model this. So just some examples quickly. We have, for example, predicting customer propensity, forecasting. Um, we have movements of the marketing. You have supply chain issue, failure of machines. All this you can do it with machine learning, looking at the data, looking at the historical information. Optimization will decide what's the price, what should be your discount, what should be your route, what should be here, for example, your production volume, right? So, and for example, you can think about like capital allocation, like asset allocation, investment distribution, all this, it will be with optimization model. Okay, so then let's dive a little bit more on how we can bring those technologies together. I will not dive that much. If you're interested in this and you're, oh, great, that seems to be amazing. So can you explain a little bit more? Call me and we have a chat and I can talk like for hours with this approach. But the goal here is to reduce that excessive inventory, right? So, and we're going to construct this both using machine learning and optimization. How we do this, we train a machine learning model to do our forecasting, to do our distribution and our vision of uncertainty for the future. Think about like what will be my forecast for the products on the next 12 months, but also what will be my range, right? So I expect this product A to be like 1 million, but it could be like 1.5 or 0.9 on the next month, right? So also like the range and the uncertainty that you have for the future 12 months. And this will be trained on a reinforcement learned stochastic model, right? So, and it's gonna make decisions using that. So you have two training process, right? The machine learning model and the optimization model, and then you do the simulations and you have your decisions. That's quite important to be able to understand your decision process, right? So, and have the human in the loop that we're gonna talk a little bit later. So let me stop a little bit here, and I want to show this initial solution that we constructed. This demo that we have constructed for pre-sales activities that to show that this process, right? So on this demo, we are doing this decision optimization inventory model, right? So we are training the second part that you see on the slide. We are training the optimization reinforcement learning model, right? So, and here you have to bring some information about this product, right? So what's like, here we have categorics, we have some data here to be, we cannot like divulgate any applications that we develop for the client. So we have some dummy data here just to be able to show, and we can use this for any pre-sales activities, right? So we have some production cost, ordering cost, there is the price, the full order size, and other parameters here, right? So with those parameters, you go and train a model, and then you can do simulations with this decision process. Here I'm showing one of the results for this simulation, right? So for example, on this model, we put a constraint on production, right? So a lot of case, your production cannot fluctuate a lot, right? So here we put a constraint that your production can increase on 10 units or reduce on 10 units, right? So, but it cannot like go from 40 to, for example, 100, right? So otherwise you don't have production stability. So you see here going like 40 on the initial 2 months, then going for 30, and then going for 20, right? So, and then when you want to go all the way to 40, it doesn't go directly there. Next month go to 30 and then to 40. So we already see some constraints of the manufacturing process here, right? So, and everything starts with this production, right? So first the model will give you the optimal production, then you're gonna join this and see what's gonna be your inventory levels with this, right? So based on your scenario and your sold products, right? So if you're able to have enough inventory to attend that demand, you sell that inventory. But sometimes here you see that you're a little bit short. The customer wants 32 units, but we are able to deliver just 20, right? So, and then you calculate your inventory and like sale loss with this, right? So you see here the case we have sale lost on those periods, right? So we're not able to achieve full demand, right? So, and you can also dive on the cost, right? So what's my cost components, right? So from the total cost here, you see order cost, ordering cost, production cost, and holding cost. And you see here for this this simple case here, production cost is the major factor, and in a lot of cases, it is, right? So production cost dominate the cost function, right? So, and you can see all this, bring KPIs, extract those values, do some investigation on that. So here, for example, imagine that we come here and, okay, I want to see a simulation that my carrying cost will have like, will lower my carrying cost. So each month I don't pay that much to have that amount of inventory. So I train the model, I simulate it here. I will not like go through this, just a matter of time to be quick, because you have to train for 60 seconds here. On production, you have to train even more. But then you have this result. So then your production is changing, right? So it changed your profile production, your inventory also changed, right? So you see more inventory here on this case, right? So, but your service level went higher, right? So then if I will be able to save a little bit on my holding cost, I'll be able to have a better service level on this process here without compromising the other parts, right? So this is one example, is a demo you can access through like EPAM VPN, right? So, and if you're interested, you can call me and I can demonstrate the demo for you also, but you can access yourself on that URL. So let's go back to the presentation. And now let me talk a little bit more of, okay, you see the solution now. And one important thing for all this decision optimization process is the steps that you have it here, right? So, and I'm also showing here, right? So what are the building blocks that we have at EPAM to help the companies independent where they are in this path, right? So everything starts with data collection, right? So you need like historical volumes, you need information from demand fluctuations to be able to do that, right? So, and we have data factoring like offering to help with that. Right? Then you go for scenario simulation, right? So, and then you start like forecasting things. So you start to go on the predictive part of the projects, right? So, and we have time series, machine learning, idea offering, and accelerators here to help the client with this step. And the last part here on the technology point of view is like optimization. Then you're deciding your volumes, you're deciding your routing or whatever you're deciding during this process, right? And then quite important, one thing that's even coming from a big academic background, right? So we neglect a lot in the issue, is the human and adjust of this process. Humans have to be able to override some decisions, right? So to have better vision, there is a lot of things that are not on the data. And if you have a model that will force the decisions into the user cannot disagree with that and cannot do nothing about it, it will end up badly. The user have to be able to see things that's not possible to see through the data, through the model. Maybe there is some mission on production line on next 6 months. It's not on the data, but the user will know about it. So the human in the loop here, the expertise has as important as this whole process, right? So, and you have to have autonomy here to help the process to become better. So if you're deciding budgets for like a cross media distribution, right? So you're investing a lot of on one of those channels, and the users see that it's not worth it invest that much because you're relying a lot on one only channel. It's optimal, it's the best cost, but maybe it's not good for the whole branding of the company. It's not good because this channel can, for example, not deliver. So the model will not have fully vision, and the human have to help the model with this process. Okay. So, and this on the PUM here, we have the data analytics practice, we have like business consulting, all this to help with this. And they will also help with all of this process here, right? So, because if you have a decision process, those are the guys that's going to tell us what are the cost functions, what's the process that you have. If you on manufacturing, you can consider it just like production cost because it's enough. The others are quite small. All this will come from those practices, right? So then finally we can dive on the KPIs and show a use case, right? So then we pick it up this, we start with an idea, we construct this demo, we demo for a company, and the company was very interested in bring this to them, right? So they want to like test this solution and they want to see what's possible to have with this, right? So we enable the company to have more efficient plan and reduce like lost sales and inventory cost, right? So we did some simulations for this and we estimate some of the savings. I cannot tell the money savings, but it's on like millions of dollars on savings, right? So even for like only one site, right? So you can have millions of dollars saved. If you scale for the whole company, imagine how much you can save with this, right? So it was very flexible in-house solution, right? So everything that they want to add on this model, they will be able to add it, right? So there is for sure some assumptions, but there is like very complex model inside it. And that's the difference, right? So you can start with that demo that I show it. That's just very simple assumptions. But then when you go to reality of the company, there is much more that you have bring, much more constraints, much more like fluctuations that you have to deal, right? So it's quite complex, but you need to model this and bring it from the machine learning model or for the optimization process. And this help us to accommodate the requirements. If you have lead times, you have to consider this on the decision process. If you have capacity constraints, you have to bring it. No linear stockouts, okay, let's model, put the function there, right? So all this we have to bring, we can accommodate and bring it to this model, right? So even as well as the machine learning model, if you have machine learning model in house for doing this, or you want to bring it some solutions from EPAN to help with that, we have to bring it and define how it's going to bring those uncertainty and use it inside the decision process. And then quite important, and I say over and over here, right? So that's the a lot of the case the companies are not doing strategic decision because they're drowning on the process and they cannot see what's the implications of the decision that they have to the future. So this is quite important. Seeing what will happen if you reduce your inventory, what will happen if your batch size increase, what will happen if you add more capacity to your production line. It's also value of millions, right? So understanding what your implications of your decision right now will be in the future, it's quite important. And this is part of our process. You have to have a simulation process for this because the user have to know what will be the implications on the KPIs. And as always, you have to deal with multiple data sources, like regarding the cost, price, historical production, and so on. And what you have after that, right? So you have like an increasing profit, right? So we test for a couple of production lines there. You can have like 4 to 11%, like we compare to actual production, right? So you can reduce drastically the inventory levels, right? So we keep seeing on companies things that we had to keep production, right? So we can have to produce because we have all the staff and we need to keep going. But in reality, what you're doing and what you're not seeing in the future, that you build up a lot of inventory. So now you have inventory for 6 months, for 1 year, and then you start to expire in this inventory, right? So if your company that this inventory lifetime is small, like you have to sell this in 6 months, then you're actually losing directly money because you're building a lot of inventory that you cannot sell at all. So you have less cash holding, much less inventory here, less stock out, right? So your stock out like reduce, so you're able to achieve much closer demand, right? So between 15 and 92, and your inventory will reduce between 8 and 42%. So this is the great results from the KPIs, right? So, but this is just the start, right? So we are talking about one process, right? So production inventory management in around the systems that we have there, right? So we have to integrate with the others. They will have different capabilities. So for example, there is efficient process of the production lines. There is stabilization of the production lines. You have this core methodology that can be used for all this, and sometimes you have different flavors. I think this is the most challenged process in the manufacturing process, right? So dealing with like the uncertainty is quite important in inventory management, but you also have like what should be your production line capacity. How much should I order from raw materials, right? So the efficient of the production lines and changeovers is when you change the production line from product A to product B. right? So there is a cost. You're changing them the machine in order to be able to produce another product, and this cost could be very small or very big. And then if it's too big, then you're having a lot of lost efficient on the process, right? So, and you have to integrate with the others. So this is just the beginning of a bigger path. And if in the future we could have like several demos going on different directions here, but this is like our start on the inventory management work. And we can stop for the QA, see your questions. Let me just change. I think I'm just on time, right?
Yeah, thank you, Silva, for such dynamic and interesting presentation. We have 5 questions in the chat. Let's start from the first one. How does the framework ensure the security of sensitive data?
Can you come again? I cannot see here. On
Yeah, sure. We have it in the comment section. You can click and open, and I'll read again.
Okay.
How does the framework ensure the security of sensitive data?
Okay. So on this case here, the user that used this application, the supply planner, or the more strategic stakeholders, they have access to everything, right? So it's nothing that they don't see it. They see on daily basis this data on cost, sorry, and others, right? So they have access to the full this data right now. For example, several of those companies, they use like Excel files in order to do this process, and they already have like the security clearance to use this data and see this data. When you open to like broad company, for sure, not all user will be able to see that sensitive data, but they can see, for example, like what's the production the production volumes for the next month, 2 months ahead. So each each group will define a little bit how the KPIs can be shown for the other users that are not like these main users of the solution.
Thank you. The next question, how did you accumulate appropriate data sets?
So I think this is one of the issues that we have over and over, right? So getting those data sets sometimes take months, right? So we have to deal with like multiple data sets. We have to integrate them together, right? So, and you have to make sure that the quality of those are good, right? So my thoughts on here is that first, we don't start as like perfect with those data sets. We start with some ideas because sometimes the process changes so much that the data set that you use in the beginning is not the same data set that you're going to use in the end, right? So then you start with something, sometimes even like Excel files, and you start interacting with the user through that data. And the user will tell you more about it, right? So we'll tell, no, this doesn't make sense. This value is not what the value that normally see. And then you change and adapt. Don't try to, before even start the project, have like a perfect data because you're going to need this and this and this. You can start with like good enough data. And then during the process, you're going to validate that. And also that's the kind of skills that data science have, right? So we can do some check on the data, check if there is like outliers, if there is any fluctuation that's weird, right? So, or any results that's weird. And the model is actually quite sensitive to that, right? So we have another result the other day that's, oh, the model is not producing this product. And why it's not producing for the whole year, right? And they're seeing the data and checking, okay, so the maximum production of this product was quite small, and the minimal order of this, it's higher than that. So then the model is actually telling you that there is an issue with the data, and it's gonna tell you, and it's gonna be more like easy to see, right? So because sometimes you have a lot of products there, you have hundreds of products, and it's difficult to dive on one specific. But you can do it both data quality report on the data, as well as see and check the results of the models if it makes sense. So start small, start with like something not necessarily perfect, and then you build up, and then normally we stop and we do it several months with just making sure the data is properly, right? So when you go for production, then take this time and create like proper data extraction pipelines on Databricks and proper data quality assurance that sometimes even on the previous project that we have quality index for the sites. some sites have very good data, so other site doesn't have. The user have to know about this, right? So, and he has to be responsible to get better data, right? So he has to be responsible to the process to be better, and he's the stakeholder that will be impacted by that.
Thank you. We have another 4 long questions and 11 minutes. Let's try to complete everything. The next one. From your experience, how often customers ask to use AI in the place they should not? What do you do with these projects?
That's a great question, right? Great question. And one of the things that I want to bring in more here to EPUB, right? So we as data science, we know we have a set of tools on our range to be used, and you need to know what's the right tool for that project, right? So there are cases that clients are asking for AI, and it's actually like optimization project, or it's actually just an algorithm project that you can actually create a procedure to decide this instead of using AI. So you have to be transparent with the client, right? So if there is no downside of using AI, and the client really wants to use it, it's okay. But sometimes there is downside. Sometimes you're gonna be suboptimal using AI for that, and that's the part that the data science has to come for sure clean and say it will be better to use a decision optimization model here. You're gonna be better, and we have someone here at EPUB that know this and can do this for. And we have done projects before and compare the KPIs. And yeah, when it's a clear optimization project like assignment, or for example, that was I can talk about this one, the use case that it's famous there for like a train company where to assign like inspectors to like lines, right? So, and they initially tried with like a rank model with machine learning, but is a decision model, right? So, and you have to model as it, and then you have much better results when you do that. So you have to come with the client and talk clean and make sure that he understands that how we want to approach this problem and how it's going to be better than using AI.
Great, thank you. The next question, with the increasing emphasis on innovation, do you think companies risk over-prioritizing AI-driven solutions while neglecting the importance of human expertise on decision-making process?
That's another great question, right? So, and you saw here that I have a slide just because of this. And the thing that I would say that on the academic side, we neglect sometimes, right? Decision making, the human, the expertise that the humans have, and sometimes we want to automate everything. Oh, we're gonna have like artificial intelligence model that will decide this, and no human intervention is necessary. And then you put in production and say, oh, okay, it was not what we expected, and the operator is on the side said, yeah, I knew that this is gonna happen, right? So I have done before a project that we were like using cameras, CCTV cameras, and look at some image and trying to understand if you have like smoke or fire on it, and we didn't test a specific scenario that was cloud behind, right? So, and then the operators, they said, yeah, we have this. We know that the cloud could be similar, but yeah, it's something that we already knew, right? So then bring this person to the process, right? So don't and there is sometimes some ego from data science to be able to it can be fully automated, we don't need humans on this process, but most of the case you need some kind of human intervention, right? So you can automate it, the best case scenario 90% of your decisions, but 10% will be like a part of the humans, and you have to put human in the loop, because sometimes it will see things coming way ahead of the models, right? So, and then even with, for example, the budget distribution project, the humans have to say, okay, your limit for investing on YouTube, it's like 10% of my budget, right? So, and okay, it's gonna cost you more, but he knows better. He knows that should not invest a huge amount of money in just one channel, right? So you have to bring this expertise, right? So, and we as data science has this also responsibility of not only looking at AI and also looking at the human expertise and bring it and make it part of the process.
Thank you. And we have 2 questions. the first one of them. How many projects that were intended to optimize decision process with AI failed from your background? Is it always a successful story?
So it's not the. So I would say that data science projects, we have a problem sometimes with the requirements and with making some visions true, because people sometimes they're thinking about something very big and very fancy, but they don't know about the technology behind. So it's a lot of the case the ideation of the whole project was done before even bringing any data science, and that's I think most common mistakes for data science project that will make it fails, because then they have requirements that the technology cannot fit, and then you're gonna fail, right? So no matter what, because you have like assumptions and reality that's it's not what technology can deliver to you, right? So, and then you have to make sure that the client understands this, right? So if you come like after the initial ideation, right? So, but have to bring it someone that know the technology, know what LLMs can do it, know what time series can do it. And here at EPAM, we have those people that are cross-functional. They know and they can direct you for you. Oh, this is a clear like time series project. Oh, it's clear computer vision project. You can do this and this, and then you talk with the specialist and say your idea, right? So this will cost you like 1 hour of consulting, maybe 1 week, and it's gonna save you a lot of money of investment on the wrong idea, right? So that's my thoughts on this.
We have another 3 questions, but I probably ask only one of them because 2 of them looks like comments. So how can AI and ML help identify the most critical constraints in a production system, and what specific tools or techniques are most effective for this purpose?
That's difficult one, right? So I would say on this process that we are talking, right? So it's both together, right? So both the machine learning model and the decision model can help you to understand this. One of the things that we see on these simulations, for example, that sometimes they have like a lot of capacity. And they say, okay, we have a lot of capacity. We have like 100 hours. Let's reduce to like 50, because that's the 50 that we are using last month. And then you see your inventory skyrocketing, because they were using that capacity to absorb fluctuations on the demand, right? So if you have this spare capacity, it will help you in the future to absorb the change on the demand. So you need to use them both on the manufacturing process in order to understand what's the ideal capacity for a manufacturing production line. If you just see like the forecast and say, oh, this is our forecast, let's go for it, and then you don't see that your forecast changes with time. So then you have to see them both together in this situation. And I'll leave this, like, if you have any questions, like, feel free to talk with me on Teams or send me an email, right? So I put here, I think the last slide is this, right? So we have like the optimization offering here also on the left. And I say thank you for
thank
all
you
of
very much.
Yeah, and thank you for the question.
Silva, could you please choose the winner who asked the best question from your perspective?
I think the human in the loop, for me, the best one. And with the increasing emphasis on innovation, do you think the company's risk over? That's for me, it's the best question that you could have right now. So,
great, thank you very much. Thank you for your talk. And for our listeners, please join our next talk MLOps inbox using Databricks in 1 minute, probably. It is going to happen right now. Hi, Jonathan.
Hey, how's it going?
Fine. Great conversation. Great conference.
I'm so
How are
happy
you?
to hear this. I'm doing well. I'm doing well. Alrighty. You can hear me fine?
Yes, sure. Could you please share your presentation?
Sure. All right. Let me. I just have to. I just have to set myself slideshow. Just because I set up slideshow presented by an individual, and then play from start, and then present. I share my screen, right? I don't share the presentation.
Okay, fine.
Is that the right way to do it?
Yeah, so I suppose yes. I suppose
Cool.
it's okay.
All right. Is it good?
It is starting. Yeah, now I can see it. Great.
Okay. Cool. All right.
Thank you. Good luck. The stage is yours.
Awesome. Do I have to do anything? I'm in the show. Everybody can hear and see me. There you go.
Everything is great.
Awesome. All right. Thank you, everyone, for coming this morning. My name is Jonathan Rioux. I'm a managing principal of artificial intelligence at EPAM. I'm also a Databricks MVP. And today I'm going to talk about MLOps in a box. I know that the title was a little bit vague for a good reason. What we're going to be looking today is a continuation of what I talked about last year. So for those who were not part of the Autumn Data Conference 2023, I spoke last year that LLM ops, so large language model operation, created a new kind of pressure on what does it mean to deploy and maintain an AI application. And we introduced the concept of an orchestrator app or an octopus app, because it has multiple legs, where you connect from first-party model to third-party model, plugins, vector store, cache. Now we have agents. We have combination of model. So the picture is definitely looking more complex. Also, another question that I left the audience with was, can you realistically talk about DevOps for LLM in that context? What I mean by that is you have a single team who should be responsible for the entire creation of your AI application. So let's use, for example, a chatbot that is responsible for delivering information that can be sensitive. The team needs to make sure that the data is in the right spot, is well integrated, that privacy is managed. So you're consuming data, you're creating your model, which means data scientific operations such as fine-tuning, ICL, reinforcement learning through human feedback or AI feedback. And then you need to deploy the app, which puts a lot of pressure on the set of skills that the team needs to have. So this is what we're going to be continuing on today. Can a team do it all? Or are we kidding ourselves? And we need to go back to a team works about the model, then a team worries about deploying, then a team worries about monitoring, which is the way that we've been doing it for as long as ML has been a thing. So today, what we're going to be looking into is can the team select the right data, experiment with it, meaning build model, register experimentation, prove your work? Then can we deploy without too much fuss? And then make sure that we protect not only the data, but also the application. Once you turn it to the world, what kind of protection and consideration do you have? You don't want your AI model to leak. All right, so I set myself to the challenge, let's have a look. Let's pick tools on that spreadsheet. Anybody who's been working in IT or anybody who's been working with ML is pretty familiar with those kind of tool map, which to me is extremely useful, but pretty darn confusing. Is the goal here for you to pick one tool for each box? Are you looking on the end-to-end, such as Data Robot, Azure ML, Databricks, Domino? Do they have full coverage? Is there anything that you're going to need to complete with? Should you complete with anything? To me, when entering this, and especially because, this is the picture for a certain month, it's going to change month over month. How do you make sure that you are actually making the right choice and that you're not wasting your time? I think on top of this, this is compounded by, you see end-to-end MLOps platform, you see Amazon SageMaker at the bottom, but you also see AWS SageMaker ground truth as a data labeling and annotation tool. Does it mean that it's especially strong there? Does it mean that it's relevant? Does it suggest that there's a gap? It becomes really easy to be confused and frustrated by the tool ecosystem and those different list cycle, which are just adding to the confusion. So ultimately, individuals that are trying to do MLOps end up just a little bit left into the dust. The tools are not necessarily integrating the way that they want. You have different process to be able to purchase them. The cost ends up ballooning very quickly. And then on top of it, it's really difficult to get yourself and your team to be able to scale in a way where you're feeling proficient and at ease with your tools. I've been on that boat several times where the companies that I was advising or even working at wanted to change platform or simplify the tool map because we're paying too much for ML, not accounting the fact that you end up with 6 to 8 months of relearning a new tool on top of your regular job. I don't know for you, but to me, to learn a new pipelining agent or to learn a new way to define workflow is not necessarily my definition of fun or something that is useful. So on top of that, last year, we've talked around the fact that an ML product is also fundamentally a data product. So you're looking into deploying your models, and you're starting with a data scientist. I was a data scientist many years ago who was using, this was even before Jupyter Notebooks, so we were using either SAS worksheets or even the first version of RStudio. And then you have to to get up to speed into the development principle, which means you need to learn Git. I think a lot of people forgot how difficult it is to internalize Git, especially if you've never used it in a team setting. It is notoriously complicated, and I think a lot of tutorials are making it harder than it is. Then you need to learn Jenkins or another continuous integration, continuous deployment tool, which means that you need to learn a brand new syntax, often a new programming language to be able to operate this. Then you're being asked to Dockerize your code. So it's another tool that you need to take into consideration. Then deployment needs to happen often in Kubernetes, unless you're using a dedicated tool for that. So you need to get familiar with Helm charts or a simplification of them, which means another configuration language and another vocabulary that you have to learn. Then most of the time you're going to deploy your model in the cloud, which means AWS, Azure, GCP, Oracle, Alibaba. You have a set of ergonomics that you have to learn. You need to understand authentication, your security model, how do you deploy resources, networking, and so on and so forth. Then on the monitoring, I put Prometheus and Grafana. There's a handful of tools there that you need to learn, but I think you get my point. And then finally, in order to be able to secure your application, you need to learn something of the kin of OAuth. Now, I want to call it like it is. Usually the solution is, well, we have a team that's going to be responsible for deploying those apps. Let's remember that when we talk about MLOps, we're talking about the convergence of ML and Ops. DevOps was meant in a way to be able to converge Dev and Ops, and created a lot of that simplification. I think the world before DevOps was a heck of a lot more complicated. The thesis that I want to make today is that we might be a few steps too far in order to be able to call MLOps simple. Or are we? We're failing. I think, by that time, everybody is understanding where I'm trying to go for. We're failing our ML team. We're accusing machine learning to take too much time to go into production, take too much time to deliver value. Model takes a long time to deploy, and there's a lot of checks that needs to happen. I would predicate it's because we haven't spent nearly enough time reviewing the processes that are necessary to do ML, and the processes backed by technology that are necessary to do ML. I think that it's high time for us to be able to put some attention over what I'm going to call ergonomics of ML tool. And, if you're looking at the title of my slides, we're going to be doing an example, a criticized example there, I say, that's going to be done with Databricks. So what I'm going to be doing today, and I mean, I think this is a record for the Autumn Data Conference. We end up going at 13 minutes after the talk started directly into a demo. So what I'm going to be doing today, and I hope I'm going to be able to change where my screen is being shared. Otherwise, that's going to be pretty boring. I'm going to define an ML job as a configuration. It's going to be a very simple one. I'm not planning on doing something overly complex. We're going to run the job, and we're going to save the experiments. We're going to review the performance. We're going to register the model. We're going to deploy, and we're going to test the model. And then finally, we're going to deploy, and we're going to demonstrate an app looking at the governance and the security aspect at every time. I will name the caveat because of practical reason and mostly because of the time. All of those steps, I have pre-done them. So I'm going to run everything. We're going to be able to see the success. Registration of steps takes usually, you know, up to half an hour, depending on how much power you put to your instances. So I've kind of prefetched everything. So you're going to have to trust me on this. Awesome. Now I'm going to see, let me see if I can do this. I'm going to do stop screen. I'm going to present. I'm going to share my screen. And then I'm going to go in. Awesome. So I think I have a virtual screen that I have created. Oh, it works really well. I'm very happy. Awesome. So the first thing that we are going to be looking into today is something that Databricks created. And this is not a tutorial on Databricks technology, but it's just to exemplify the point that I wanted to make. This is something that is called a Databricks asset bundle. Databricks calls all of their resources assets for the purpose of this tool. And as you can see, the configuration is YAML, nothing overly complicated. I think every key is pretty self-explanatory, but I'm going to go through it. Here, we are defining a job, which is basically a series of tasks. For those who are familiar with other task runners, such as Luigi or Airflow, this is basically your directed acyclic graph, so DAG. Here, we have a single task. The model that I'm using is a very simple logistic regression. I didn't feel like, you know, we needed to go overly complicated, which predict if something's going to be a dessert. For those who have seen my PySpark book, this is the ML model that I use to exemplify the different processes of building an ML model on PySpark. I'm using a notebook, although a Python file that Databricks just runs as a notebook. It's already running on a cluster. I just defined the cluster ID. I could also configure a new cluster as an asset to be able to run it. I target a workspace, which is an internal workspace that we are using to run our experiments and look at advanced functionality. Databricks does not stop there. You can also define dashboards. You can also define database, schema, tables. You can register and deploy models using asset bundle by configuring them. I just felt like it would make for a pretty boring demo to just present a single file and then run everything. So this is the asset bundle. I'm going to use my command line. I will pray that the yeah, we're already off to a good start. There we go. ADC. There we go. And then I'm going to do Databricks. I think I'm going to be logged out. So it's oh, wonderful. I am logged in. Perfect. All right, we're already off to a good start. I'm going to just show. So I have my Databricks file, and I have my model training that is over here. I'm just going to be Databricks bundle deploy, and I have multiple profiles on my machine, so I'm just going to define the default profile, which converge to the environment that I have. what happens behind the hood, and we're going to talk about, you know, specific tools. Databricks is actually creating a Terraform plan for the resources that I want to deploy, store them into a secure environment. So you don't need to learn Terraform to use Asset Bundle. Then it's going to make raw API calls to be able to trigger the start of the job if you're requesting it. And then will also stores the different assets that are not triggered by a Terraform, such as dashboards and applications, so that they are in a secure place within your Databricks environment. So I feel like we're already off to a good start. I have my source file, which we're going to see in the Databricks window. I have my YAML file that has defined what I wanted to do, and a simple command line makes it easy for us to go and have a look. Awesome. So for those who are not familiar with Databricks, the user interface is divided into a few sections. Today, we are not going to look at SQL, and we're not going to look at data engineering. We'll focus on the machine learning aspect of things. Bear in mind, Databricks Asset Bundle can also be used for your data engineering jobs, which suffers from the same problem. Awesome. So first and foremost, I'm just going to make sure my cluster running? My cluster is running. Fantastic. I'm going to be looking at my my ADC demo dessert, which is connected to Asset Bundle, and I'm going to be looking at, here I have my file for my model training. You can see here, it's nothing too complicated. A cool thing around Databricks, for those who are like me, not the biggest fan of Jupyter notebooks, Databricks stores their notebooks in, they're compatible with Jupyter notebooks, but they have Python files with special comments, which means that they're a lot easier to version control, which makes it pretty easy to use. Over here, I'm reading my table. I'm creating a pipeline that has a series of steps and do a logistic regression. So basically, I do imputation, assembly of features, I do scaling of features, and then I put my logistic regression. For those who are interested in knowing a little bit more how the ML model is done, I have a discount code for my book, and I can also send you the chapter in question if you ask me nicely. Do my random split, train the model, and then perform the test. There you go. I'm actually going to connect here because that's going to make it more visual. And then I compute a series of metrics. What I want to show and what we're going to look into is that all of those metrics are going to get reflected into my experimentation UI that we're going to see in just a moment. I'm going to run this, and I'm going to pray that this works. I ran everything yesterday. I don't see why it wouldn't. And I made sure that we had plenty of power. Wonderful. This ran, this is running. It's going to run for approximately a minute. We're going to go. You can see here, over here, MLflow is auto-logging some runs. Basically, MLflow, which we're going to see in just a moment, is the best way that I can describe it is Git for ML experiments. So ML models that you train create artifacts. So usually you have your training data set, your testing data set, and you also have a package that basically takes your raw data and transform it into prediction. That I don't want to use the word bundle because I think it's going to confuse people with the Databricks Asset Bundle, but that package needs to be versioned, needs to be kept track, because you might be running a handful of experiments. In our case today, we're just doing one straight pass, and you're going to see the accuracy of the model is nothing to scream home about. But you might experiment with different parameters. You might experiment with different modeling strategy. How do you know which one you want to keep? How do you know which one you want to deploy? And also, how do you want to keep track of how you build those experiments? What were the ingredients to make it so that you don't repeat yourself constantly? All right, so we have logged one run. It's going to take a little bit more time than what we expected. I blame the morning. I'm just going to make this bigger for all of our intents. And in the meantime, I'll prepare the other tabs, which are going to be experiments, models, and serving. While this is running, I already have a batch that is already ready that we are going to be able to look. I'm going to go into the experiment tracking. I'm going to go into the one on the 26th. This one is the one that is being done this morning. Why do they have a different name? It's because this one has been done using the bundle. This one has been done interactively. So you're going to see the location of the file is going to be different. So Databricks tracks experiment based on the file that has created the training. So we are going to look at this one. And today, the experimentation, you can see I've done a number of experimentations. Some of them have failed. You see there's no models that has been compiled. This one is the one that we are going to be looking. Databricks has the quirky way of naming using an adjective, a name. Usually it's going to be an animal and then a number. Sometime it can be a little bit risque. Today we have Big Bird 352. So something that ran for 4.3 minutes, so 4 minutes, I would say 15 seconds, a little bit more than 15 seconds. And then we see that we have two data sets. So the Databricks actually kept track, because we are using data that is in a data source that's managed by Databricks. They actually watermarked the data sets that we have used. So the one for training and the one for evaluation. So I can go and look and do my evaluation if I want to see that the data sets are balanced, if I want to see if there's any testing records that are not, testing variables that are not reflected in the training set, and so on and so forth. So very, very cool. I have my area under the ROC curve. So this is the metric that I'm going to care about because I'm using a classifier. If I wanted to add metrics, I have the option, as well as a handful of parameters of the variables that I'm using. The model is basically taking how much protein and how much fat, as well as the calories and the sodium of a recipe, and try to predict if it's a dessert. So nothing too complicated. Where we're going to go is we are going to look into the artifacts. So inside of that experiment, MLflow is managing a series of files. So you have the environment in order to reproduce this. MLflow is using Conda. So basically, those are the dependencies that I have. If there's any specific Python dependencies, this is a little bit of a quirk that they've done. They create a Conda environment, install some dependencies via Conda that are easier to get at version or vendor using Conda, and then they use pip on top of it. It feels a little bit redundant. It's just to to be able to accommodate, depending, regardless of which tool you're using, you're going to have the option to run the model. There's also an ML model YAML file, which gives you the entire way that you need to run the model. I want to bring your attention to the signature over here, where you have your inputs and your outputs that are specified. This is something that is tremendously important. This is how the rest of the system, the rest of the ecosystem that is compatible with MLflow is able to track. Not the best syntax in the world. I'm not a big fan of like string that represents data types, or it just looks a little bit jarish to me. But it does what it is supposed to do. So we have a ratio of protein, which is a double and required, calories, which is a long that's required, sodium, which is a long that's required, and fat ratio, which is a double that's required. Where it gets interesting is if you have null imputation on certain fields, they can become optional. So if you don't pass a parameter and they are there's a process into your pipeline that does null imputation, you can specify it as not required. So very interesting overall. A few elements that are related to how this is going to, how do you calculate the estimation? So how do you compute, like what are the different stages to go from input data set to output data set, as well as how you compute the metrics. Here I'm using PySpark ML. If you were to use scikit-learn, TensorFlow, Prophet, MXNet, you would get different files here. And then the last thing over there is my Spark ML, which is the actual, I don't want to use compiled code, but the actual code that gets me there. Awesome. So we're going to go back into the model. You can see over here with the model schema, you can also have an option to validate the model before the deployment. To me, this is amazing. You don't have to remember the code. I think this is very, very good ergonomics. Let's have a look here. What I've done is I moved from the experiment back into my notebook. You can see over here my area under the rock is it's okay. It's fine. I'm actually quite pleased that it doesn't hug the one too much. I think it's always suspicious when someone gives you a model super precise. But you can see like my precision and my recall is nothing to scream home about. It's not a good model. Like I think we have to get comfortable. Like this is not a good model. Awesome. So I have my experiment that is over here, and one of the things that I can do after this is register my model. As you can see here, my model has been registered. The reason why I've done this in advance is because it takes a little bit of time on this endpoint. So my model has been registered as dessert. And this is where things are going to get a little bit interesting. For those who are not used to using Databricks or have used another MLOps tool, you can see that we're back into the catalog. And more importantly, this looks like a database, and it's very much by design. Databricks has unified the governance of all of its artifacts using their catalog. So this is the main catalog. This is the default schema or database. And under it, I have 8 tables, 7 volumes, which volumes are governed directories. So if you want PDF, Word document, images to be there, you can drop them here, and then you can give permissions around the volume. So it's a replacement for dumping stuff in S3 and praying for the best. And then we have our model. So I have a version 1. I can add tags, aliases, comments, you know, everything that you want. I can also use, I mean, actually, why not do it this morning? It gives me actually an AI suggested description, which is garbage. Main catalog default schema, very nice. I could have figured that out. Represents data related to desserts in the business, providing insights and analysis, sales popularity, and customer preference. Absolutely abysmal. Completely wrong. So I'm not going to add it. But you can use you know, description to describe what is your model about, what are some of the restrictions that you have, who owns it. You can change the owner over here, add tags if you want to be able to propagate this into your logs. Details, we're going to skip pretty quickly. And then where it gets interesting is that you can grant and revoke permissions of this. So what I'm going to do today is, those are inherited because of the default of the main over here. But I could grant access to all account users over here to execute the model or apply tags to it. Right now, Databricks does not allow anybody but the owner to make modification or delete, which is, you know, a limitation of the platform. So I'm going to give them the option to apply tags because it's a little bit less risky. And then any account user that have access to Databricks is going to be able to add tags to the model. This is really nice because it means that this artifact now is governed using the same vocabulary that you've been using for securing SQL data assets since, you know, as far as SQL security was a thing. So you don't have to relearn anything. There's no new vocabulary to learn. I find this to be extremely cool. Now that we have this model over here, we are going to go and serve this model. If I were to click, I think it's going to bring me to a serving endpoint, which already exists. I'm going to show you. I have already done it. You give a name of the endpoint. You decide how much traffic. You decide if it's going to be a CPU or a GPU if you're doing large language models. Scale to 0 if you want to go. And if it's an internal model and you're okay with the cost going down to 0 and having a cold start to happen when it comes down, you can do it. You can do budget if you want, and where it gets interesting is you can also specify an inference table. So main default, I would name it dessert. I've already done it in my other example, which we're going to show in a moment. That becomes pretty useful. Your monitoring of your model comes for free, and to me, this is a good example of something many data scientists struggle with, is the moment that the model makes prediction, what tools do you need to orchestrate to be able to get visibility over it, and how can you do monitoring of your ML models? Other products that I've used, such as Datadog or Splunk, are notoriously expensive. You already have, you know, the infrastructure to be able to store the data. Databricks does streaming pretty well. Why not use it? So I'm going to go into my serving endpoint, which has been modified over here 28 minutes ago. And then you can see here my endpoint is ready, and I'm going to be ready to see if my model is going to work. So I'm going to cheat. I have a request that I can do. So for today, 30% protein, 200 calories, 0 sodium, and 40% fat. Is it a dessert? I'm going to go to my query endpoint. It's going to take a little bit of time because I think I have to de-cold start my endpoint, but we're going to get to the bottom of it. All right. In the meantime, I'm going to prepare the last part of the demonstration that I wanted, and let. So I'm going to go into compute. Let's see. I'm still querying my endpoint. Yeah, I'm not. I should have probably queried it just before. The last thing that I want to discuss with, and this goes directly into the Octopus or orchestrator app that we were talking a little bit before. Databricks now has the option. Oh, this has been. They stopped it. This is a bummer. So it might take a little bit more time. I might actually take questions and then be able to show if this is going to work. There you go. So I have my inputs: protein 30%, calories 200, fat 40%. Not a dessert. They've predicted that this was not a dessert. What if I, get this 10% of protein and 1,200 calories? I will be like, I don't know what the parameter space of the model is. So there you go. So this happens to be a dessert, which, something that's quite, if you get to think about it, like 50% of the calorie comes from carbohydrates, 1,200 calories, 0 salt, which suggests something that's going to be pretty sweet. I think it makes sense here. But as you can see, I have my exact signature that I have here, and I have the response that I can test. You also have the option to do it via Karol for those who use the command line. You can also do it via Python, which is pretty phenomenal that they provide you with the code to get started. And something that is quite nice for those who are more SQL inclined. Databricks offers, if you're using their Databricks SQL product, they give you access to calling the model to every record on your SQL database. So if you have, for example, in that case, it's a little bit it's a little bit funny over here. But if you wanted to do sentiment analysis on some text, or if you wanted to do forecasting in a batch process, it's a lot less code to do it with a SQL query than it might be with PySpark or with Pandas. It also opens the ability for people who may not be familiar with the data science stack to use your AI models in a way that is a little bit more interactive, a little bit less stiff, and get you the results that you want. Okay, so this is the compute is still it's still running. Of course, the demo went super well. Something needed to to not work. I'm gonna let this running for a moment, and I will go back to my presentation just to be able to conclude and ask question, and then we'll finish with a bang and just show you a simple application that we have deployed, show you the governance of the application, and then explain why it matters. As a matter of fact, yeah, let's do it this way.
Okay.
Awesome.
Thank you. Thank you very much, Jonathan. It was really insightful, and it was the first workshop on this stream today. and your expertise and practical approach enriched our session. Let's go to the question part. Firstly, thank you very much for your expertise in the chat. And we've got 3 questions. First one, how do Databricks simplify the journey from AI models to production-ready applications compared to competitors?
And so this is a very good question. I will say I'm a huge fan of Databricks, and I think it's because this is where I got my chops on it. There's other extremely interesting platform. Weights and Biases is also one that is especially compelling into the LLM world. I mean, as a matter of fact, OpenAI is using Weights and Biases for the own management of their models. I like to consider, especially when we focus on the app side, I think it's important to call it out. Databricks Lakehouse Apps is a very simple product. It is in preview right now. You don't have the option to scale. You're limited into the there's only Python apps that can be supported. So if you want to have something, I know a lot of people love using TypeScript for a full stack, which is not necessarily possible. It's not for internal app, for something that you're creating as a proof of concept. I think the integration with Databricks is an absolute game changer. You don't have to use another product. It's already there. It's already secured. It's really, really nice. For more, if you are on the Snowflake side, Snowflake acquired Streamlit, which means that Snowflake has the same option to be able to deploy apps. If your needs are more, I would say you still want to stay within the Python ecosystem and you want to go something more enterprise ready. I think the very expensive Dash by Plotly is pretty much what I would consider best in class. The key differentiator, as you said, to simplify the journey from AI model to production application, you wouldn't use Lakehouse apps or Databricks apps if you were not a Databricks customer. I think it makes little sense in that context. It's really the integration with the system, which makes it easy to use the same vocabulary throughout.
Thank you. And the next question is serverless compute already supported to run jobs with notebook? It is on the screen now.
Correct. Is serverless compute already supported to run jobs with notebooks, Python wheel task with asset bundle? Yes, but not all jobs. There's still a series of limitations. I mean, as a matter of fact, when I was preparing this demo, I have a serverless environment that I was very excited to use. ML libraries are not well supported, and it's still very much a work in progress. So it is not recommended to use serverless right now for ML workload. I ran into a series of issues, and between you and me, I don't really like debugging tools that may or may not work in the end. Also, on top of this, you're also limited into the types of libraries that you can install. So there's certain data engineering workload where you're not going to be capable of installing certain libraries because of the nature of the serverless product. It's evolving. What is true today might not be true in a month, but it is something to stay vigilant. Databricks has, to give them credit, a pretty good documentation around this. In order to use serverless with asset bundle, just leave out the cluster information. Databricks will default to a serverless deployment if you don't specify a cluster.
Thank you. And the next question, which is better for migrating machine learning models from our Databricks workspace to another using MLOps, Azure DevOps, or GitHub?
That's a very, very good question. I prefer. I think it's easier to do things with GitHub in general. I think the reality of it, especially as you're mentioning bundle, and when we're talking around bundle, the workflow that the Databricks recommend is you're not going to move the MLflow artifact from one place to the other. The catalog is not workspace bound. So when you promote a model to the catalog, you know, the main default dessert, it becomes account bound. So your experimentation that are happening into your dev environment, the moment that the model gets promoted to Unity, it's already available in every workspace that is federated through that Unity. So you don't really need to migrate anymore. Your question might relate to what happens if you don't use Unity, if you're using the legacy way of deploying the models. Databricks in that case recommends legitimately retraining the model in production, and because it also gives you confidence that your pipeline is working overall. I know now that it might be cumbersome if you're not, especially if you have a model that requires a lot of resources. But I would predicate that if you train something just once, is it really reproducible? But if you're asking me like which like Git provider I prefer, I've used GitHub a lot more than Azure DevOps, and I find Azure DevOps UI to be pretty user hostile, but that's just a personal preference.
Thank you. And now please choose the winner. What question is the best from your perspective?
Holy smoke! Yeah, this is a little bit unfair. I'm going to yeah, this is very I'm gonna pick Toka because she went first. I think the question was really well worded. I think it's very pertinent. Congratulations.
Okay, thank you very much for everything. And to wrap up this incredible day of insights and innovation, I am pleased to pass the word to Bogdan Guy, who is Director of Software Engineering in EPAM. Bogdan will share some final thoughts to close our conference. Bogdan, the stage is...
Hello, can you hear? Stage is mine.
Yeah.
Hi, Jonathan. How was your last performance? Did you enjoy it?
Every year is better than the other. Thank you for having me.
I'm so glad to see you with us this year. So your slot is reserved for 2025. You know it. So, all right, guys, Victoria, Jonathan, my sincere congratulations and gratitude to you. And then I know, Jonathan, it's today's Thanksgiving in US. You know, I'm not sure if you're celebrating, but I'd like to this opportunity to say thank you for all what you did to as a contribution to this conference success. Okay.
Thank you.
Yeah. Okay. Let me share my screen, guys. One moment. Okay. Just one moment. Here we go. Is it visible? I believe it should be visible. Oh no, it's not visible. Hold on. Let me reshare.
Yeah, it's visible. Everything is fine.
Yeah, but not full screen. Yeah. Yeah. So I will share my screen one more time. Yeah, sorry for that. Okay, now should be better. Yeah. Okay. So guys, conference is coming to its end. Yeah, it's a bit pity, but I wish I had a chance to stay listening to the speaker's performance hours and hours, right? But anyway, this is where we are. No speakers ahead, so let's summarize the event. So my congratulations to the winners. You guys made our day. Lesya Volovets, Mike Finko, Andriy Royko, Irina Patsevko, Andriy Muraц, Denis Taranenko, Andriy Muts, Victoria Timoshenko, and Nadia Birban. So you guys did your best, crafted the best questions for our speakers. So they have awarded you with our prizes. Please contact Maria Mraka, and she will share with you the details how you can obtain your prizes. Yeah. So this year we have India and Latam as location with us. So I wish I see some speakers from these locations, right? Hopefully, like next year, they'll be more active, and we will see speakers from those locations. Anyway, it's time is up, guys. I would like to express my gratitude to the entire org team, Maria, Alexandra, our video engineering team, our designer team, who actually worked very hard to make this event happen. Also, our speakers, which demonstrated their best-in-class topic, and they were very well prepared. And I hope you guys enjoy this event. So also, please don't forget to leave your feedback. We definitely will take this into account. We are trying to improve ourselves year over the year. Right, next year, I promise this conference will be way better. Yeah, definitely with your help. So see you all in 2025. Yeah, please reserve your slots. Bye-bye.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.